by cloud, we'll try to understand first. So the NIST definition, the National Institutes of Standards and Technology definition for cloud is it is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Okay, so the most important thing to understand in this definition is configurable computing. Okay, configurable computing resources. It is like asking that I want X instant of time. I need a computing resource which probably has 4 GB of RAM. Okay, and say 100 GB of hard disk. Okay, possibly 4 cores of CPU. Okay, 4 cores of CPU. Core means you understand. Several decades ago, we used to have single core computer. Now we have multi-core computers. Okay, and by means of hyper-threading, the power of computing resources has increased immensely. Okay? Now, cloud computing is a paradigm of computing wherein we will be able to access computing resources by sitting at a remote place. Okay, I'm using the term remote place because initially cloud was developed for such a situation. But nowadays, even though you are not in a remote place, you are always trying to use cloud resources because the cost of accessing cloud or cost of computation over cloud is much cheaper than buying some resource and maintaining it. Okay, for example, if I want to use for some work, for example, I just want to use, let's say, a very powerful server. Okay, then I have to make a lot of investment on the server and then a lot of investment on the software. Okay, and the software could be perpetual or subscription based, and then I need to pay the maintenance charges for the software, updates I need to do, for that I need to pay, right? And also to keep the server in an environment wherein the performance is good, I need to keep the environment cool. So it should be in an air-conditioned environment and so on. Okay. So all these aspects.
Sir, excuse me, sir.
Yeah, tell me.
Sir, which slide you are showing, sir?
In the first slide only. I'm in the cloud computing slide, first slide.
Cloud computing overview, sir.
No, I am in the second slide, cloud computing NIST definition.
Now it is changed, sir.
Okay, now
we are seeing cloud computing NIST definition of cloud something. One diagram is there. Now it is changing, sir. Cloud and virtualization.
Okay, I think it is slow. Okay, I think okay, fine.
Okay.
So whenever I change the slide, I will tell you that the title of the slide. Then you can probably quickly check.
Thank you, sir.
There could be some. Yeah. So as I told you that that when we are using a cloud service, then the main problem with us is that we cannot really buy a computing machine, host the machine ourselves, and then make all the arrangements for the computing machine to run efficiently. Okay, and therefore we go for this cloud-based model. Okay, what do you mean by cloud-based model is clear now. Okay, so we can always rent a machine from a pool of computing resources, which can be reconfigured. Okay, for example, Amazon is a very good service, cloud service, wherein we can rent some machine for a desired period of time, 1 day, 2 days, 1 week, or 1 month, and so on. Okay, for that we need to pay a price. Okay, so when we are asking for a resource, we are always asking in terms of the CPU power, RAM, probably the disk space, and so on. All these things we are going to ask for from a cloud service. Okay? And based on that, we are going to get some response, and then we start our computation. We offload our computations to the cloud, and then we get the results back to our machine. Okay. So when I say our machine, it means that we are going to get it to a PC in our environment, which is not really so powerful as that which is hired from the cloud. Okay, that is what it actually means. Okay. So fundamentally, we are still in the first slide, which is cloud computing. We are talking about NIST definition. So fundamental points for which for the cloud computing are as follows. So one is the on-demand service, broad network access, resource pooling, rapid elasticity, measured service. Measured service is in the sense that we need to pay for what the time we are going to use it, as I told you, 1 week, 1 day, or 1 month, and so on. Okay, on-demand service. Whenever we need it, we can get it on demand. Okay, And network access is strong. Resource pooling means what? We can get as many resources as possible, which is based on the limit given by the Amazon kind of web services or cloud-based services. Because cloud service of Amazon is called Amazon Web Services. Therefore, I'm talking about that. Okay. Then we have something called rapid elasticity. Okay. That means while you are working, while you are connected to the cloud, if you need really an additional resource, okay, if you need an additional resource, then immediately you can scale your requirement. Okay, so for example, you had a 4-core CPU. Now suddenly in the next instant, I need an 8-core CPU. You can always ask for it. That's what is rapid elasticity. Okay. Now I move to the next slide, cloud and virtualization. Hope it has changed now. Is it so, sir? Cloud and virtualization.
Yes, sir.
You can see.
Yes,
Okay,
sir.
fine. Now, what do you mean by virtualization? So, Amazon kind of companies, what they do is they try to host many powerful servers in their data centers. Okay, and most of the data centers are in cold countries, so that the cost of cooling is reduced. So most of the Amazon data centers will be in the cold countries. What they try to do is any server, very powerful server, they break down the server into multiple logical partitions. Okay, it is not that really hardware is divided, but it actually means that a kind of software called hypervisor logically partitions this hardware into multiple parts. Okay, so you can see here there is something called virtualization layer. On top of it, you are getting two partitions. There could be multiple partitions depending on the underlying processing power of the cloud of the server. Okay, like this, there could be several thousands of servers connected in network. Okay, so such servers, each of the server being partitioned by some kind of virtualization called virtualization is a technology. Okay, is a key enabling technology that is done by a software called hypervisor. So we are going to partition a bigger chunk of the computational power into smaller chunks. Okay, and in that smaller chunk, each of the chunk will act as one computer. Okay, but however, this part, each of this part, we'll call it as a virtual machine. Okay? Each of this part, we'll call it as a virtual machine. And on the virtual machine, we can host any kind of application and so on. Of course, since this virtual machine acts as a computing unit as such, you can have your own operating system. Based on that, you can upload your own application. Okay. Similarly, all the servers on the cloud will have their own virtual machines. Okay, and there will be a pool of virtual machines available for the user who can interact with the cloud and get certain virtual machine. That means there is a possibility that a user can request certain type of virtual machine. So therefore, what cloud services have done is they have given certain types of virtual machines which user can request a priori. Like we go to a restaurant and ask for menu, right? Similar to that, cloud services will give you a set of virtual machines from which you can choose from. Okay, that is the way it is done. Okay? So you can see on the right hand side, so hardware, CPU, RAM, and hard drives, etc., is partitioned into multiple parts called virtual machines. Okay. So now cloud is fundamentally divided into three major entities. One is the private cloud, one is the public cloud, and the hybrid cloud. So public cloud is like Amazon cloud. Okay. A hybrid cloud is a combination of private cloud and public cloud. For example, an engineering college can always host a private cloud. All right. Like for example, assume that Amazon Web Services is helping you to set up a data center on your own, and it is giving you all the cloud software for you to host services for any number of users in your college. Okay, so in such a situation, you can call it as a private cloud. That means it is restricted to the users of your college. Then you can call it as a private cloud. So generally, what is done is private cloud and public cloud. When we talk about, so we use public cloud if we use public cloud only when necessary. Then we call this combination as a hybrid cloud. Okay. So, for example, Sri Rama College Engineering Management sets up a private cloud, and if the users have crossed the limit of this private cloud computational capacity, then they can always decide and get access to public cloud like Amazon. Okay, that kind of combination we would call it as hybrid cloud. Okay, so whatever is the combination here, the main purpose of cloud is to give computational resources to users. Okay, on demand. Okay, now there are two things here. One is the computation resource, and then second is a management software, which will, or management controller kind of thing, who is going to manage all the user requests. That means, for example, an Amazon cloud could always can get requests from multiple users. Okay, then how do we channelize the requests in terms of the available resource in Amazon itself? Okay, there could be several thousands of servers in Amazon, with each server having several virtual machines running at any time, any point in time. But the problem is there should be a way to manage the resources. Okay, for that there are management algorithms which run on separate servers, which will try to tackle the load from the users. Okay, it is load from the user in the sense that there will be several users which will be requesting for resources. So this management service will try to divert the user request to different virtual machines. Okay, so that they get the right hardware and software required. Okay, in terms of virtual machines. All right. Now I'm going to the next slide. Is it there now? The next slide. You can see some plots and all that.
No, sir. Now it is visible. Cloud computing pros and cons.
Now?
Graphs are visible, sir.
Yeah, that's graph. Yeah, exactly. Yeah, graph thing is there now. So you can see here that if you use a powerful server, I'm just telling you this one, the advantage of cloud. If you host your own powerful server, then the problem is you can just check the utilization of CPU on disk over time. You see here that the blue line, okay, the blue line is a utilization of the CPU, and then the disk utilization you can see here over a period of so many hours, okay, 19 hours. You see that most of the time, if you see, the disk is not being utilized properly, and even the CPU is not being utilized properly. That means if you are having your own server, okay, then if you look at the utilization, it's not so good. Okay, so therefore, what you want to do is you don't want to host your own server. You want to use a cloud for it. Okay, that means this kind of server will be in the form of virtual machines in the cloud. Okay, and you are requesting for it. That means wherever you can see this blue odds, right, in the peak. At those instances, whenever there is a demand from your side, at that time you are requesting for more and more resources from a virtual machine which is there on the cloud instead of having this powerful server. That is what is indicated here. Okay. So the management software which I was talking about, management service which I was talking about, is also called the load balancing. That means there are many users on the left hand side. There is a cloud on the right hand side. Okay, and then you are diverting the request via the load balancing. Okay, it's a kind of management service. Okay, so this is what is actually the crux of the cloud computing. So now, what is the problem with this one? What are the pros and cons? I hope you are able to see the slide on pros and cons of cloud computing.
Yes, sir.
Yes, okay, thank you. So if you see the pros and cons, you have auto scaling, choice, and agility, next generation architecture. These are normal advantages. Okay, what we should be really careful is the right hand side, the cons, the problems with the cloud. Okay? So one is the mathematical model. Is it possible to really develop mathematical models? Why do we want to develop mathematical models? Because as I told you, that one Hello.
Hello, sir.
Yeah, hello. There is some background noise. I think. Yeah. Now is it okay?
Now it is okay, sir. We will instruct you.
Yeah, some people are talking here. Okay, fine. So now in this situation, the main problem which comes up in cloud computing is that you don't have mathematical models. Since I'm a control engineer, I will talk about control theoretic models. Okay, there are very few mathematical models which can clearly give an indication of how the cloud behaves over user requests. Okay, that is what is the first point. Second is the security. Is your data secure? Okay, or you are getting exposed to anyone who is logging into the cloud. Okay, reliability. Is it reliable or not? If you are ordering for a virtual machine, you are connected to the virtual machine. Suddenly, you can lose the virtual machine or not. Such kind of problems exist. Okay. and the solutions are being found day after day. Okay. Now, next. Okay. So therefore, we use control systems to have a kind of a closed loop system wherein you want to see to it that any user is requesting for a cloud service, he gets it. Okay, via some feedback loop. These are all control system basics which I don't want to get into now. Okay. So now I am in a slide wherein you can see several PCs connected together via network. Can you see that?
Yes, sir.
Cyber Physical Cloud Computing Laboratory, IIT Madras. Okay, so here if you see, there are several machines which are connected, and this was my experimental setup for my PhD. During that time, I had done this. Okay, so generally a cloud setup, if you want to do it in a private space, right? For example, in your college or possibly in a small working environment, if you want to do, you can do like this. Okay, so this is the architecture of the cloud. I am in the slide of Eucalyptus cloud architecture, wherein the requests come from the client side. Okay, and first they will hit the service of cloud controller, all walrus. Okay, and then there will be cluster controller and all that, and then finally this client request will be routed to a virtual machine. Okay, this is the way the cloud works. Okay, and all these machines, okay, all this cloud controller, cluster controller, and the node controller, which hosts the machines, are time synchronized. By NTP service. Okay, NTP service means Network Time Protocol Service. Okay, so because there is an information exchange between the cloud controller, cluster controller, and the node controller, so they should be connected with the same network for time synchronization. Okay, therefore we use the service called NTP. So I'll skip the kind of architecture and all that now, but since I do not want to talk about cloud too much, I will get into fog computing also. But as I told you that for cloud computing, the most important thing is that we need the user can request for certain type of virtual machines. Okay, why this is important? You can check here, because Amazon will offer you a type of virtual machine which is M1.small, C1.small, M1.large, M1.extra large, C1.extra large. Okay, what is the actual meaning of it? Forget about this max VMs here. You can see that M1.small is a type of virtual machine which can actually give you a computational power of 1 CPU, 128 MB RAM, and 2 GB hard disk. Similarly, C1.small would give you 1 CPU, computational power. Then you have a RAM of 256 MB and 5 GB. Similarly, the other VM types. That means a user can request only these types of virtual machines. And these max VMs are based on whatever setup I had during my PhD. Okay? Now, this is the situation. Okay. Now, I'm not going to this also. So, what is the way? If you see this diagram, okay. So, in my research, what I did was I hosted web servers on the virtual machines. Okay. I hosted web servers on the virtual machines. Okay. So each web server, what happens is that is hosted on the virtual machine. I'm hearing some noise. I'm hearing some background noise. Okay. So this is an experimental setup for hosting web server. Okay. Now where does AI come into picture is what we need to talk now slowly. Okay. So any AI algorithm is generally used for inferring something. Okay, for example, we'll take some case studies. Like for example, in a shopping mall, we want to detect what are the types of items available in the shopping mall. Okay, in such a case, we should know. Okay, we should know a mechanism for inferencing. Okay, inferencing means that from an image, for example, in a shopping mall, if you are able to collect a stream of images, okay, you need to instantaneously find out what is there in the image frame. For example, you go towards grocery side, you have an image of the groceries, okay, 3 or 4 images of the groceries in the same frame. Then you should be able to find out what are the items in that frame, okay. So that is a kind of AI, okay. That means, for example, if I move a mobile robot in a retail environment, okay, if it captures the stream of images and then from each frame of that image, if you are able to identify what are the items, right, then that is a kind of AI. Okay? So what generally is done is, if I use a cloud in such a scenario, what I would do is I will use an AI algorithm which is being hosted on each of the virtual machine like this. What you can see here. I hope you are able to see the slide on instrumentation for the cloud. I hope you are able to see that.
Yes, sir.
Yeah. So if I'm talking about, even though whatever I'm talking is not related to this figure, what I'm trying to tell you is, so each of these virtual machines, I'm going to host an AI algorithm which can take input as the images, and output it will give you the type of items in those images. Okay, image frame. Okay, that means image frame will be the input to the virtual machine, which will be hosting the AI algorithm, and the output would be what are the items in that image. Okay, image frame. Okay, so this is the way an AI algorithm can be hosted on a virtual machine. Okay, so instead of having your own computation in your college, you can host this. You can host this AI algorithm on the cloud. Okay, that is one way of doing it. Second way is to host it on a fog computing environment. That also we'll talk about later. So this is the way this whole thing is done. But the problem here is when you talk about virtual machine, right? So this virtual machine is a kind of operating system, as I just told you. It will be very similar to the operating system, and we need to upload all the softwares necessary for running the AI algorithms. Okay, AI algorithm would be probably in Python and so on. Okay, for that the virtual machine should have Windows. Then on top of it, it should have all the prerequisites to run the AI algorithm. Okay, therefore there should be a way to develop that virtual machine. There should be a way to develop that virtual machine. To develop that virtual machine, there is a process called image management, wherein we take the raw image of an operating system, and then on top of the raw image, we try to install all the prerequisites required for the AI algorithm. Okay? And then once we form a virtual machine with the AI algorithm, we try to upload it to the node controller. Okay? So that's what happens actually. Okay, so this node control is a machine wherein your AI algorithms will be running on the virtual machines. Okay, that's the main crux of the story. I'm hearing some background noise. Maybe you can mute from your side. Those who are the participants, please mute your mics, okay? Because I'm able to hear some kind of noise.
I request all of you, please mute yourself. Ram Mohan sir, Rama Mohan. Sir, we will try from our admin side, sir.
Yeah, okay.
You continue, please.
So where is it?
Speaker voice not audible, sir.
Yeah, now are you able to see the slide?
Yes, sir.
Okay, thank you. So all of you, please mute your mic so that whenever.
Sir, speaker mic is.
Yeah, I don't know. It is. Yeah, now it is on, right? I don't know. It is happening automatically. I'm not doing anything from here. So
no, sir. Yeah, you're not doing. I think admin doing unknowingly.
Yeah, admin people, I think you should not touch the mic. Okay, fine.
Thank you.
Yeah, if it is not audible, please tell me. Okay, so now we're talking about this cloud and fog robotics. What do you mean by cloud and fog robotics? Okay, so let's try to bridge the gap between what do you mean by cloud, what is by fog, and then slowly we'll take it into robotic side. Okay, so as I just told you before, cloud computing, we are asking for some resource from the cloud like Amazon Web Service. Now, what do you mean by fog computing? Okay, so fog computing is a little milder version of cloud, wherein we need to process information on this on a set of computing resources which are not really as powerful as the cloud. Cloud means servers, and then from that you get the virtual machines, right? In fog computing environment, the computing resources could be like microcontroller, like Raspberry Pi, Arduino.
సార్
and
మ్యూట్
all
ఆల్
that,
ప్రెస్
okay?
చేశాను
They can
ఆయన మాత్రం
form
అన్మ్యూట్
a
చేసుకోమని చెప్పండి సార్. ఎవరు సార్ ఆయన ప్రజెంటర్ ఎవరు సార్? యూత్ సార్, యూత్ ఎవరు లేరా? పేరు చెప్పండి సార్.
Sir, your mic is muted, sir. Please unmute.
Oh, yeah, I don't know.
సార్ ఆయన
Somebody is
ఫోన్
doing
చేశానని
it.
చెప్పండి సార్.
I am not even touching the mic.
Yes,
so
sir. Yes, sir. Thank you.
I don't know. Sorry.
ఓకే రామ్మోహన్. ఓకే ఆయన
Okay,
అక్కడే
it is.
ఉన్నారు సార్,
Don't worry.
అందరూ మ్యూట్లో ఉన్నారు.
So if there is anything which you are not able to listen, just
Okay,
tell
sir,
me, because I am not even touching the mic here. Okay.
సరే.
So now, where do I use AI for robotics? Okay. As I just told you that if I have to do some kind of inspection kind of application wherein a robot could move in a shopping mall, and then you want to find frame by frame what are the items in a shopping mall as you receive it from the robot. Okay. In such a case, you could use fog computing, wherein you could process the information, okay, from the frames immediately on the onboard computer or a network which is very nearby to that computer, okay, to the onboard computer. So what you can see here is that you can see here a set of video frames, video capturing, and then you have frame extraction, image. There are several steps going on here, okay? And then you are trying to offload your computation to a small fog environment, okay? That's what will actually happen, okay? So even though that part is not shown here, it actually means that the several steps of frame extraction, image restoration, image enhancement, and object detection, all these things, okay? So all these things take place on AI modules, which are hosted on a small network called fog network, okay? And each of the fog network would have its own computational resource such as Arduino, Raspberry Pi, and so on. Okay? So we form a network of small computational resources such as Arduino, Raspberry Pi, and all that. And on those resources, we are going to allocate this algorithm or host this algorithm. Okay? That's the way it runs. Okay? So the difference between cloud and fog, for participants who are there now, you should understand, cloud is a really powerful resource. Okay? Fog is a milder version of cloud, wherein the computational resource is not so powerful as the cloud. Okay? So for example, Arduino, Raspberry Pi, you cannot compare with a virtual machine's computational power. Okay? So that's the way it runs. Okay? So fundamentally, when we apply AI for robotics, okay, by means of cloud and fog, it is called cloud or fog robotics. Okay, the fundamental purpose is that each of the algorithms which are there in the steps you can see here, each of those algorithms would be hosted on a fog environment. Okay, that's the main purpose of it. Okay, now fine. Let me go to the next slide. Okay, you can see that here also. So there are several operations being done by a robot here. I hope you are able to see the complete environment here. Is that clear?
Yes, sir.
Wherein you have, left side you have certain robot and then it is doing something, right? So the operations could include pick and place, decluttering. Decluttering means you mix up a set of objects and give it to the robot. It is going to separate it and give you. Okay, even though it is not a great operation to do, it is just for a certain type of training. Okay? So that is one thing. So now, if you want to really have an architecture for the robotics kind of environment, or a cloud robotics kind of environment, only thing what is going to change here is either you can see in this diagram, I think you can see two parts. One is pre-processing, one is post-processing part. Okay? There are several robots here. You have the robot vision data, which could include a lot of information related to the images. Okay, and that is getting pre-processed in this server called Fog Robotics server. And then is finally being sent to fog computing for one layer of processing. Some part of the processing of the robot vision data could be accomplished in a fog environment. Or sometimes, if it is really powerful, the whole part of it can be always processed in the fog environment. If it is not so, then you balance the load across the fog environment and the cloud environment. Both. Okay? This is the cloud environment. Okay, this is what I was describing previously. This is the complete architecture of the cloud environment. This is fog. Okay? So each of the fog, you can see the modules. They could be kind of microcontrollers, Arduino or Raspberry Pi. Okay? So this is a very transparent. Now where are we in terms of the whole thing, right? So AI means that you are talking about, if you can see this slide wherein there is an intersection of robotics, people and machine learning. I hope you are able to see that slide, right? I hope you are able to see that. So you have this intersection of robotics, computer vision, of course the humans, which is shown as people here, and machine learning. Machine learning is the AI algorithms. Okay? There is some intersection. And that intersection actually represents that you are actually trying to develop an application in that direction. Okay? There's so many things involved. Okay? So if you're talking about robotics, you will be talking about image processing, computer vision, and so on. Okay? So that is what is shown here. Human, why people are here, human is there because sometimes in some applications human intervention is all. Okay? Not just by programming, that is not human intervention. Okay? There could be certain algorithms wherein the algorithm loop is closed only when a human intervention is there, otherwise it will not be closed. And then machine learning, okay? Which is the actual crux of the whole thing. Okay, this is a part. Now the whole logic runs like this. If you can see this, the whole thing, the whole control loop, it is called see, think and act. Okay, that means you are sensing from the real world. Okay, that means you are actually sensing from the real world by means of some sensors, and then you think. Think means actually you are running some algorithm, and then based on that you are going to act on the system. This is what that means. Even though I was talking about some simple application like detecting of items in a shopping mall, this real world environment could be like that. Okay, that means you are sensing some image frames from there, and then based on that you are trying to see what are the items, and then when what do you mean by act? Act here is that a mobile robot could move from one place to the other. That could be a very simple way of explaining this loop. Okay. Now this loop we could talk about, if it is a mobile robot, then we could talk about this loop as a cascaded loop of two things. One is the dynamic controller, one is the kinematic controller. Okay. So the advantage of this is that we can follow a reference trajectory using this combination of controllers, kinematic and dynamic. Okay. So if you see, we had done some experiments in our lab wherein we tried to move this robot in a certain environment to follow a certain path. Okay, and this robot would carry a kind of camera which can capture this environment. That is the way we have developed this application. Okay, and then we see here, we tried to see to it that we follow different paths. Okay, one is the elliptical path, and then we try to see different controllers. Okay? Even though I'm not mentioning any control logic here, but for tracking, we follow LQR plus state feedback, LQR plus H infinity control, or SLQR plus H infinity. SLQR means switched LQR and H infinity control. Okay? So these are some type of path tracking algorithms which we've developed. Okay, and then the error also tries to reduce as we go to a complicated controller from the left hand side to right hand side. Okay? The most difficult part is to generally trace an 8 using a robot. So that is also done with these three controllers, wherein we find that SLQR is having the least error. Okay. This is another shape, square shape, and so on. Okay. So for fog computing, what did we do is, initially, even before we got into the shopping mall application, what we tried to do is we tried to first take a mobile robot like this with a very simple camera there, okay, and then of course a computer to see what is happening from this camera, okay. So to view what is seen by the camera, this computer is being used, okay, and then we have certain colored balls and Raspberry Pi. So what we did is, if you see this application, so first what we did is we made a boundary like this. I hope you are able to see this slide on preliminary results object mapping. All of you are able to see? Yeah. So when we are using this one, in this situation, so this mobile robot is given a path to trace this simple square, okay, and then in between you have these balls, okay, with different colors, okay. So now what we did is we tried to move the robot from the initial position, and the final position is of course the initial position after tracing this trajectory, okay. So what is the difference between the results that we observe, okay? So now, if you see here, there are two types of things we have done. One is we use onboard computation of the mobile robot to process the images which we receive of this environment, okay? This environment images at each point in time as we travel this trajectory is monitored here, okay? So for example, I am at a speed of 20.5 cm per second. I am at a speed of 30.5 cm per second. Let's say I am moving so fast here, okay? So now the speed is increasing. Now, and I am capturing these images and processing these images using the onboard computer of the mobile robot. It is another microcontroller, alright? If I am doing that, what I find is as the speed is increasing, as the speed of the robot is increasing, I am not able to observe the balls here. Okay, so here you could probably at a lower speed, you are able to process some frames properly, whatever frames you are receiving, process. But as the speed is increasing, you are unable to process the frames there. Okay. Now what we do is we process with different speeds. We process the frames using a separate device, which we call it as a fog device. Okay. We process the frames received from the robot using a separate device, which is a fog device. In that case, what would happen is the number of balls remain the same irrespective of the image, irrespective of the speed. Sorry. Okay? So that is the main observation which we make, that when we use fog computing, that means when we are using an additional computing resource than the onboard resource, we will be able to gain in terms of the accuracy of detecting an environment. That's what is the main experiment. Okay, so now here we have used just a simple Raspberry Pi, so we could get some results. Otherwise, if we have used a more powerful device than Raspberry Pi, a powerful microcontroller than Raspberry Pi, we could have got better results. Okay, so of course we got these results and then we could write a paper on it. So now what we see is, if I use a single onboard controller, okay, if I use a mobile robot, same environment just I talked about, right? If I use, I hope you are able to see the slide on background, right? Single board controller and all that.
Yes, sir.
Okay, fine. So if I use this situation, what would happen is, if I use single onboard controller, what does it mean? Single onboard controller means that I am using the onboard computational facility of the mobile robot to capture the environment surrounding it. Okay. So in such a case, processing time is much above threshold time. Okay. Now, what would I do is, in such a case, I would distribute, for example, in the previous case, whatever we discussed, if I distribute the image frames across several Raspberry Pis instead of one Raspberry Pi. Okay. In such a case, the amount of time required to detect an object in the surrounding of the robot is much less. Okay. Then there is a question now. Okay, why do you want to use so many Raspberry Pis here? Okay. Now the quality of the image is going to get distorted due to several things based on the camera, based on the speed, and so on. Okay. So all this processing has been divided into multiple AI algorithms. Okay. And all these AI algorithms are organized properly, and they have been uploaded onto each of the nodes of the fog. Okay? That's a node 1 is one fog device, node 2 is one fog device, and so on. Okay? So this load balancer, which you can see here, which comes from the which actually takes all the frames from the mobile robot, will distribute the number of frames equally among these nodes. Okay. So what would be the control objective here? The control objective here would be to see to it that whatever be the number of frames, you distribute the frames across a certain number of nodes so that you process each frame in a certain amount of time. And that time I would call it as service time. Okay? That time I could call it as service time. So the control philosophy is to change since I have no control on the number of frames coming up or the quality of frames which are coming up. So the only thing which I have in my hand is to change the number of nodes here. So that acts as a control input. Okay? One more thing. For instantaneous object detection, each of these nodes has this TensorFlow object detection algorithm which runs on each of these nodes. That is a kind of AI algorithm which runs on this platform. Okay? Right. So all the nodes will be uploaded with this TensorFlow object detection algorithm, and it will be trained for detecting certain type of objects. So the problem which you would have is that if I am receiving more frames per second, then only the nodes will slow down. Otherwise, there will not be any problem. Okay. So as the number of frames increase, the only thing what you need to do is here, using control algorithm, you need to increase the number of nodes and redistribute the number of frames to the new set of nodes. Okay. In such a case, you will see that the time required for processing the increased number of frames is also reduced. Okay. So that's the way the control algorithm works. That's what we did in our paper. Okay. So what we call now, this is the introduction slide. Don't need to worry. I have talked about all these things now. This is the whole figure which I was talking about. I hope you can see the slide on introduction with the complete block diagram. Are you able to see that?
Yes, sir.
Yes. Okay. Thank you. So here you can see on the left hand side, this is a mobile robot which is moving in a shopping mall. We just did this experiment in Tirupati, in one of the shopping malls. So it has several sensors which are captured. This is a mobile robot with camera and so on. Okay, all the proximity kind of sensors and all that, which are available on this one. And have the navigation controller, of course, which is attached, which is actually navigation control loop is an algorithm which runs on the mobile robot hardware, okay, or microcontroller. Okay. So near to that mobile robot, we developed a fog computing platform and a cloud computing platform so that the robot can interact with it. Okay. Now the question is like this. Now, is it possible that all my computational demands can be met by a network of fog nodes? Yes or no is the question. The answer is no, because as the number of image frames are going to increase and increase, I may not be able to cater to all the processing all the image frames, okay, within a certain amount of time, which I'm calling a service time. So therefore, only fog platform I cannot use it. Okay, given the number of frames. If the frames are increasing beyond a certain threshold, I cannot use the fog computing platform. Okay. In such a case, I would use a cloud computing platform. The only difference would be in fog computing, I will have small nodes. Okay, that means computation power of these nodes will be little less compared to the virtual machines in the cloud platform. So this is a basic difference here. So once you know this difference, there should be something called a load balancing controller, which will divert the frames from the fog and the cloud. Okay? That is the main thing here. And each of these node, either a virtual machine if you take or a fog node if you take, both of these computational nodes will be hosting this TensorFlow AI algorithm, which will be used for detecting an object. There are several steps which is shown in this block diagram. Just the TensorFlow collection has the way the TensorFlow is trained is shown here. Now, these are some experiments which we did. Here it shows that you have the situation of the first situation is the onboard controller. Second situation is for the fog environment, okay, wherein the number of image frames is well within the threshold. And the third case, we have a situation wherein the frame per second, the number of frames coming in are more than the threshold. Okay, so this is a problem. Okay? In the first case, if you you change, if you see here, you just use the onboard controller. You can see here. Then what is happening is that as the number of frames are increasing and decreasing, you can see here, right? There are two things here. One is the frame rate and the image resolution. Both are shown here as frame rate and image resolution. Okay. And then if there is a variation in this frame rate and image resolution, you will see to it there's service time variation also in the first subplot. Okay. However, if you are using a fog computing environment wherein you can change the number of nodes, okay, in an onboard computing environment, you cannot change the number of nodes. The computational power remains the same always. You can see the dashed line in the middle plot. So, if we are changing the number of nodes over time, in such a case, the service time also changes over time. Okay, so this is not desirable. So, if I want to keep the service time constant, irrespective of the changes in the quality of the image and the frame rate, which is the number of frames getting applied to the fog computing environment. In such a case, the control is possible. Okay, if it is fog computing, I can change the number of nodes and I can get the service time to be in limits. Okay. So now you see here in the second middle plot, which is this slide is motivation slide. Okay. So here, if you see that if the FPS threshold is less than the desirable threshold, okay, so frame rate is less than some value. Okay, that means it can be handled by the fog environment. Okay. So whenever there is a change in the frame rate and resolution, you can see in the second and third subplots, you can see that the service time I can keep it within 2 seconds. Okay, let's say my objective is to keep the service time within 2 seconds. I can do that here. Okay. So next is here the third case. There is a possibility that the frame rate and resolution can change so much that the fog environment cannot handle the service time beyond a certain value. Here you can see here the service time I have asked for 2, for example. Now, because of the changes in the resolution and the frame rate, you can see here the service time is crossing the limits. Okay, so therefore, I'm coming back to the introduction of this block diagram slide where there is fog platform and cloud platform. Okay, so whenever there is a change in this frame rate and resolution beyond certain value, the service time also changes beyond certain value, which is not desirable. Okay? Therefore, we need to apply cloud also. That means that if you see this slide, that means some part of the images should be diverted to the fog computing platform, and some of it should be diverted to the cloud computing platform. Okay, so these are a couple of slides which are mainly focused on the theme of this FDP. Okay, theme of this what you call the topic which I am talking about. So please pay attention. Okay? So now that's what I just talked about. Okay, this is all control part which is related to. I'll give the reference for paper reference so that you can have a look at it. Okay? And then these are the types of items which we try to train. Okay, it's not just that the TensorFlow algorithm will directly take care of the what you call detection of these objects. You need to train. Okay, different types of items have been trained. There are several items, around 30 to 40 item list has been trained for the TensorFlow, and they have been hosted on the fog and cloud environments. Okay, that's what we did actually. Okay. Now this is the schematic diagram of this one. Okay. Then I don't want to get into this because probably it's an algorithm which probably needs to be explained. But the only thing which I would like to tell you is that we have developed several load sharing algorithms, okay, which are used for diverting the load across the fog computing environment and cloud computing environment, so that the service time could be kept within some reference value. Okay, that's what you can see here. And finally, what we did is we tried to run the whole thing, which is the real-time validation here. Okay, it shows that there is a working environment of a shopping mall wherein the mobile robot moves from one part to the other part. This red marks, I hope you are able to see the controller validation plots, right? Application environment. Hello, is it okay? I think you are able to see the plots.
Yes, sir.
Yes, okay. So in this case, you can see there's occupancy grid map and so on. The path planning with obstacle avoidance is shown here. Okay. So what the robot does, it traces the points which are cross points. Okay, they are called the waypoints, and then you reach from the starting point to the ending point. Okay, within this time, what is happening? Okay, so you are actually distributing the load in the sense the image frames to the cloud and fog environments, wherein you can record service time independently. Okay, and at each point in the shopping mall, at each point, you will see that the frames are changing and the resolutions are changing. Okay? And based on that, you are able to distribute this load across the cloud and fog environments. Okay? Now the number of nodes in the fog environment are shown in the blue here, in the last plot here, and the number of machines which are used in the cloud are shown in the red plot here. Okay? So this is a kind of validation which we did in a shopping mall in Tirupati. And this we published in a top tier 1 journal in robotics called Robotics and Autonomous Systems. Okay? You can see the paper. I'll also share the link. So this is a kind of control, navigation control loop, which is used for the mobile robot. So what did we do here? So there are a lot of things involved here. We tried to mathematically model a fog computing environment, and then slowly try to develop a controller so that the controller understands the dynamics in which the fog computing environment changes with respect to the the nature of the computing environment. For example, the image frames are changing, image resolution is changing. How does the service time change when the number of nodes are changing? So that information is captured in the mathematical model. Okay, and that we describe it as an LPV model. Okay, LPV means linear parameter varying model. Right? This is what it means. So once we have the LPV model for a network of fog nodes, which we also call here as the distributed fog computing environment, DFC, or distributed computing environment, we develop this controller called LPV controller, which is linear parameter varying controller. Okay? And these all we do it to ensure that we get the service time to be below a certain value. Okay. Let me conclude this part of the lecture for this. Let me conclude this in a proper way. So what did we do probably till now is we tried to understand the cloud computing. Then we talked about fog computing, which is a milder version of cloud computing. Then I said cloud computing means virtual machines. Fog computing means that we use a lesser computational power like Raspberry Pi, Arduino, or a microcontroller. Okay. The commonality between cloud and fog is that the AI algorithm which we actually host on the cloud or a fog needs to be trained. Okay. For example, in my application, we had a mobile robot which is moving in a shopping mall, capturing the images in the surroundings, and then while the mobile robot moves itself, we need to find out what is the item in that given frame captured by the mobile robot. If we have to do it so fast, we don't want to do it on the mobile robot's onboard computational facility. So we offload the frames, image frames, to the fog computing network, wherein there are several Raspberry Pis, okay, each of them hosting the AI algorithm, and then once the Raspberry Pis receive this frame information, they immediately reply back saying that this is the item in the image. So that is the main purpose in which the fog computing, cloud computing, and the robotics, mobile robot, and the application is a shopping mall application. So this is a complete integrated application which we tried to develop at IIT Tirupati, and we have a good amount of 2 journal papers on this area. Okay. The other area which we talked about, which are not really studied now, we recently worked on UAV-based image processing. Okay. That means you have a UAV or a drone which actually moves in a warehouse kind of thing, capturing images. It has to go completely around the warehouse. It has to capture images, and from a centralized place, it has to give you, at a centralized place, it should get the information, what are the items in the warehouse. Okay. So that is another kind of information. And possibly based on the barcoding that we have done using barcode. Otherwise, if we have to stock check manually what are the items are there in our warehouse, or at any point in time if we want to check the stock, it becomes really difficult. So we have to do it using UAV technology. That's what we do here. Right. So how much time do I have now? I need to do it another half an hour. Can you please tell me?
Yes, sir. Yes, sir.
Approximately half an hour.
7:30.
Yeah, 7:30. Okay. Maybe I'll do 20 minutes and maybe 10 minutes for questions.
Okay.
So that people also have some chance to interact. Now, so let's try to understand the application area. So in our case, we talked about a simple situation, not really simple situation, but a situation which actually ties up cloud computing, cloud computing, a real world application of robotics. All these things have been done. So what about the real world application? Okay. Real world application. Now I'm on the slide of Industry 4.0, necessity of cloud and all that. Okay. So what is Industry 4.0? It actually is an integration of several devices. I can vaguely say this, but actually, as per definition, there could be little difference. Okay. Industry 4.0 is a platform which integrates several types of devices. Okay. Several types of devices. You can call them as IoTs. There's several types of machines. The robot could be called as machine. All this integration is very seamless. Okay, seamless in the sense that if you want to access data from one device to the other, it becomes really easy to do that. This platform is called Industry 4.0. It's a kind of platform. Now, the Industry 4.0 has come up with the different kinds of industrial revolutions. The first industrial revolution is the fourth industrial revolution. So, fundamental part of the industrial revolution and Industry 4.0 is the IoT, the Internet of Things. Okay. It's a simple IoT chip which we can talk about. Okay. This is the market share of the IoTs in different regions. I hope you're able to see the slides: healthcare, manufacturing, electricity. So this is a slide which shows the partitioning of the IoT device across different sectors. Now, what is Internet of Things? It is a network of physical objects, devices, vehicles, buildings, or any other items, embedded with electronics, software, sensors, and network. It enables these objects to collect information. So, when you talk about the fundamental thing which is is that you have a device. If you just go 40, 50 years ago, we never had IoTs, right? We just had a simple sensor, right? For example, to measure temperature, we could have used RTD, which is resistance temperature detector. Now, RTD by itself cannot exchange information with any computing device. Like, for example, cloud and fog, for example, today, it cannot directly interact with RTD. Now, for example, if today you need to interface RTD with the cloud and fog, that means the information from the RTD, if we have to pass it on to a fog environment or cloud environment, what should it do? Okay. So we would have to develop all the signal processing of the data which is coming out from the RTD. Because temperature, in the sense, there is a lot of noise coming in. Okay, so all the noise can be reduced by using some kind of Kalman filter or some kind of observers. Okay, or there could be some basic filters like low-pass filters also. So all these things should be on a chip, which is very near to the RTD. Then you should also have possibly a network connectivity. Okay? Like we have the Ethernet port. Like that, we should have a network connectivity. If it should get connected to a Wi-Fi network, then it should have a Wi-Fi kind of port. If it wants to connect to other devices, then it should have a certain interface. Okay? So what I mean to say is, an Internet of Things which we have now, has completely different capabilities than what we had before. Initially, 50 years ago or so, we had sensor to be different, signal processing unit to be different, and so on, and network device to be different. We had three distinct entities. Now you have everything combined together in one chip. Okay. What will it do? For example, you have an IoT chip, what you can see on the slide, the first slide what you saw. It will measure temperature, will do all signal processing corresponding to that temperature, and then it will transmit that image also, transmit that data also. Okay. So it has three capabilities: so processing capability and networking capability. So that makes then IoT. Therefore, a thing means a device, and internet is actually what. Therefore, it is called internet. So there are several application areas, and then there are several layers also, which are called sensing and identification layer, network construction layer, management. So, okay. So if you see this layer of an IoT, okay, there are several IoT devices nowadays being used. Now, if you see these layers here, the main problem happens here is with the information processing. I hope you're able to see this slide of Internet of Things, IoT, wherein there is need for computational power. I hope you're able to see this slide. Will ensure that I'm in the right slide for you also. Yes. Hello.
Internet of Things slide, sir.
Yeah, Internet of Things, and you can see some different layers, right? The need for computational power, right?
Yes, sir.
Yes. Okay. I think we are on the same page. Okay, fine. So if you see here the sensing, network construction, all that, this different levels of Internet of Things. Okay. So sensing and identification is okay. Network construction is different kind of protocols by which different devices can be connected, and then they will be fed to data centers. It could be cloud or fog environments wherein the information will be processed. Okay. Why I'm talking about IoT now is there could be IoTs, and then we need to process information coming out from the IoTs. So that depends again on the type of data. The data could be image data, data could be text, it could be video, it could be audio as well, right? So different type of data sets could enter the data center, wherein you need a kind of computational resource to process this image. There again, we talk about cloud computing and fog computing. Okay. For this volume of data which we have here, we will definitely go for cloud computing. Okay. So now in this architecture, where do we fit fog computing? Fog computing we can only fit in the first layer. Okay. Before we will be in this first part wherein you have sensing and identification. At this point, we can really use a fog network and then do some pre-processing and then to send it across the network. Okay, that's the way we are going to do it. Right. This is the most important point which you should highlight here. Okay. Fine. So there are cloud-based setup. There are some platforms. Don't worry about this. It's called Anagon platform and so on. So don't worry about this slide also. So quickly we'll go through different types of IoTs which we use in daily life quickly, so that you get an idea of what is IoT and so on. So this is like there's an iPad which can give you the real-time information from a sensing, which is NetAtmo, which can give you the temperature and humidity, air quality. This is a kind of sensor here which can immediately get connected. Okay, possibly by Bluetooth and so on. This is one kind of IoT. IoT is what here? iPad is not the IoT. IoT is this part, NetAtmo. This device is called IoT here. Okay, and iPad and mobile here are used to visualize this data. That's the advantage we get in IoT. So once we have an IoT, we will have an app in a mobile or an iPad where we can actually see what is the data coming in and so on. This is a smart pill. So this thing this will be attached to your stomach. Okay. So what will happen is that once somebody takes a pill, there will be an ingestible sensor in the pill. Once this pill is taken inside, this sensor is called a wearable sensor, which I showed you backside. That will detect that the pill is taken. Okay. So this is a time wherein the patient care has become a big problem. There are so many patients coming to hospitals. We don't know which patient has taken which medicine and so on. So this is a kind of IoT device which can interact with which is ingestible pill. You see, sensor is ingestible. That means it can be digested also. Okay. But then before getting digested, it would give an indication to the wearable sensor that this pill has been consumed. Okay. So this is a kind of IoT device very at the micro level, right? Then this information is passed on to a computing device. It could be iPad, or doctor could have this iPad who can receive the information over a wider network. Okay, this is one type. So there are devices which are used for checking the location of where your pet is, like a dog. If you are having a dog with you, possibly if you want to check where it is, okay, in a network, in a given space, the network, it has RFID tag and so on, live location tracker and so on. Then travel cards is one this thing. Magic bands in Disney, wherein you can enter in some places with a band. Okay. And there is one popular example wherein somebody wants to give you this bottle, and then he wants to send a message in the bottle. Then just have a QR code here, and QR code gives you some message. Okay. This is one kind of IoT application. This is another application wherein, for example, if you're walking in a street, and if you're running some application, in that street, the IoT device will transmit some information regarding the items in that street. For example, there are many juice shops, there are some hotels in a given street. Then once you're going through that street, what would happen is that given an application on a mobile, you will get pop-up messages that okay, the juice is here, just $2, please have it, and so on. And probably it could give you the map where the shop is and so on. Okay, but it's not really a complicated street. Okay. And some information related to real-time information from IoT is related to the schedule of the buses. The bus is really late, okay, or if it is coming early, that is really not possible. But if the bus is late, then you want to find out where the bus is using live tracking and so on. That is one possibility here. Okay. Then you have smart sensing in some of the mobile phones, which can sense your heart rate. That is one type of IoT application. That means, so you can see here that an IoT is integrated in your mobile, which can really find your heartbeat from your blood flow, okay, pulse rate and so on. Okay. And some application related to the counting the number of steps of your activity and so on. And you can have locking and unlocking of a door via a mobile. Okay. This also happens by IoT-based actuation, which happens from the mobile and so on. These are really advanced stuff. Okay. You can lock it from a remote place. For example, if you forgot to close your door using manual lock, can you lock it automatically via some arrangement? This is some kind of arrangement. This is also IoT technology. Okay. For industry, you have you can close and open a valve from a remote place using different technologies of wireless or Bluetooth and so on. So IoT design this is what is all about IoTs. Okay. So why did I talk about IoTs? Is because each IoT generates a different kind of data or a combination of different data sets, okay, which need to be analyzed to come to a logical conclusion. Okay. Like for example, in Tirumala, since we are in Tirupati, we are talking about Tirumala, wherein we want to control crowd, right? There is a lot of crowd here. Okay, so if you want to check the density of the crowd, then probably each of the pilgrims should have some kind of wristband which can actually give the live location of the pilgrim, so that you know at what point how many pilgrims are there and so on. So it's a kind of traffic management thing. But that kind of thing can be done using IoT. So the context of IoT is brought in here because the fact that IoTs generate huge data. So that data needs to be processed. Okay. So where do you want to go from there? Can it be processed in a fog computing environment? Can it be processed in a cloud computing environment? Is the main question now. So whenever you have such large data set, you will never go for fog directly, because you cannot dump the whole data in fog computing because it's of low computation. So therefore, first what you do is you try to do some pre-processing steps in fog computing and then transfer the information to cloud, wherein the whole processing can take place. That's the general architecture we follow. So these are all some slides on that. So what are the potential research areas for control? So whenever you want to control a process, we talked about two computational environments, fog and cloud. Now let's look at cloud. For example, we'll talk about this cloud and fog, and then we see that what is the distinction we can make, especially with relation to control. Why I'm talking about control mode. What I mean to say here is that if I use cloud and fog environments for processing the data, pre-processing the data or processing the data, then how does it affect the control? Okay. Let's say I want to control a boiler here, for example. You can see here in this plot you have criticality versus sampling time. Okay. And you are talking about round trip time, because either cloud or fog are at a certain distance from the actual application. Okay. Let's say I want to do boiler control from fog environment. What does it actually mean? It means that the fog environment is taking the boiler data, is doing some preprocessing, and it is actually running a control algorithm and sending it back to the boiler. Okay. It is generally not done, but just being shown here as a criticality here. Okay? Now let's say, for example, if you want to do real-time boiler control, power plant kind of thing. So the latency time, the round trip time should be very less, right? Generally, we cannot achieve such kind of round trip time in a cloud environment. Impossible. Okay. So as we move towards the right-hand side, you see that cement mills and rolling mills, all these things, the control sampling time is 1 second. That means every 1 second you can update the controller, okay, the control logic. Okay. Similarly, solar and wind turbine control sampling time is 10 seconds. So as we go on the right hand side, the requirement for the cloud and fog increases without any harm. Okay, as we go on the left hand side, the criticality increases. Okay? So based on this, we need to see whether we can actually go for a cloud environment or a fog environment. What is the application of robotics? Okay, robotics is there is one Da Vinci server. I think this is one paper which I downloaded, and this is ROS-based system wherein you have a Hadoop cluster. Okay, it's actually a distributed computing platform. Hadoop is a distributed computing platform wherein the information from the mobile robot is integrated via ROS to the Hadoop cluster. And this server is called Da Vinci. This is another kind of application. This is cloud robotic application. Network robot is another kind of application wherein you network, you interact, and you run all your robot algorithms on the virtual machines on the cloud, and also you have some interaction between this. For example, you want to do some formation control, or if you want to do some kind of activity together. And formation control is one type of activity which you do together. Now look at the industrial automation applications where, as I told you, that in industrial automation, we use something called advanced process control and SCADA. These two are the most important industrial applications. In this kind of applications, so the fundamental architecture is like this. You have the field dividers in the bottom. This is actually called the pyramid, which is classical pyramid. Classical means it was possibly more than 5 decades before these architectures were being used. Nowadays, this architecture is changing. Okay? So what we have here is the field devices in the bottom. And these devices exchange information to the HMI and PLCs. Of course, PLCs then the information exchange to HMI. HMI means the human machine interface. And above that, there are MES, management execution systems, manufacturing execution systems, SCADA, APC, advanced process. So as we go upper, it is more of management. As we go down, we have more of sensing. In between, we have control. Okay? So this is the way it is done. So now people thought, why do we actually use a PLC or a computation machine like this? Because in this second layer, third layer, and so on, we would need computation resources. People thought, why don't we use cloud here? Okay, and therefore the next architecture I'm going to show you is cloudification. Cloudification means instead of having a hardware PLC like this, you would host this control on a cloud service. Okay? That's called cloudification. That is what is here. Okay. So this is the cloudification of the entire platform. That means you don't have physical hardware. All the information which you get from these devices in the bottom layer are being transferred to the upper layers. Okay. The upper layers. Upper layers means that dump all the information to the cloud where all the control takes place. Now, if you want to do the control, depends on the plant. Okay? The plant requirements have low latency requirement, you can never apply cloud. If the requirements are, the latency requirements are high, that means, let's say 5 seconds or 10 seconds, then of course you can use cloud. Because the closed loop feedback control will require such kind of arrangement. Okay? This is a cloudification. Okay. So this ends my lecture. So please feel free to ask me any questions because we have some other 10 minutes before we start giving you the lecture. Thank you.
Hello, sir.
Yes.
Thank you, sir. Thank you. A wonderful session, sir.
Thank you.
I request participants, any questions, I'll
as a party president, my request.
Yeah. Any questions, please ask me. Yeah.
Instead of a participant, I have one question, sir.
Yeah.
Sir, is there any this cloud robotics and robotics comparison we did in electrical machines for fault diagnosis in windings or any other thing?
Yeah, that's okay. So, see, it is not about, fault diagnosis is a very good area to work on, okay? Machines, electrical machines or any mechanical system, electromechanical system. Fault diagnosis is the most popular method wherein you can do fault diagnosis in real time, okay? If there is any problem, you can find out in real time. Your question is exact in that direction. Now, the only problem is if you measure the parameters from a machine, okay, there could be winding temperatures, winding currents, winding voltage, and so on. Any electrical and non-electrical parameter, certain algorithm which will be able to generate some information regarding the faults in the system is what you need to find out first. Okay. If you are able to do that, then the second thing is you need to find out whether that is computationally intensive algorithm or not. That means if you are getting data set in real time, are you able to compute real time information or not? Real time, are you able to find out the fault on? Okay. If it is not possible, then you go to the cloud for computing. So that's the only thing. There will be definitely some papers. It's a good area to work on. Yes.
Hello.
Yes.
Hello.
Yes.
Am I audible, sir?
Yes. It is audible. Please.
Good evening. This is Ravikant speaking from Pune, Maharashtra.
Okay.
My question is regarding what are the research area or research, what we can say, the scope related to this machine learning approach or deep learning approach or cloud computing or big data regarding energy storage system, like battery, supercapacitor, or how we can manipulate or how we can get the data using different logic for this energy storage system, for it either for it hybridization or for itself.
So you want to get the data sets, you say that, right?
Yes. Actually, because to get a machine learning or for deep learning, etc., we need ample amount of data regarding this energy storage system or its hybridization. So,
Okay.
is there any kind of particular logic, like right now in with Python, there is a regression analysis or like that. So, can you specify any specific logic or any particular thing that from which we can get maximum data, or which you will suggest that it is efficient for getting a machine learning concept for either identifying the battery life or life estimation or SOC estimation or etc.
Okay. So that's a good question. So I generally don't work in the battery domain, but I'll give you a general answer for this question. Okay. So what the thing is, so whenever you are talking about a system, now let's say you are talking about a battery system wherein you need to know the state of charge and so on, right? That will probably health of the battery. Okay? So that means first SOH, right? So if you want to find out that, first you need to see what is the data I'm getting, at what rate I'm getting the data first. Okay. And then once I get the data, is there any algorithm? Just as I answered the previous question, you need to see what algorithm can be used to process the data in real time. Okay. So if it is computationally demanding, then only you go for cloud and fog. Okay. So for each application like battery and probably whatever I talked about, the mobile robot and so on, each application there will be certain, you need to identify certain AI algorithm, or you need to write your own algorithm and possibly call it as an AI algorithm. Okay. So that is very custom.
Sorry to interrupt you, sir.
Yes,
Let me
yes.
simplify my question actually. Just forget energy storage system. My very simple question is, you need to generate any kind of data for implementing its life estimation or implementing using that machine learning approach. Which algorithm would be the best suitable? Let us assume that air compressor or pressure vessel or whatever, whichever machine is there. If I want to generate ample amount of data for machine learning or for its that particular machine life estimation, which algorithm would be suggestible from you?
No. It's generally we don't suggest any algorithm. So the way researchers work on a problem is like this. First is, if you're talking about a system whose health you want to understand, okay, first you should know the mathematical model of that system. Okay. So if you can match the mathematical model of the system with the behavior of the actual system, then possibly you can generate a lot of data. Okay. So unless you match the mathematical model, for example, in control, we use linear parameter varying model, the most simplest framework. Simplest is the most complicated framework as well. Okay. So LPV, right? So once you develop that kind of model, then automatically in simulation mode, you can generate a lot of faults in the model, and then you can get a lot of data. Okay. And logically
So
speaking,
there is no short or kind of easy approach or simple approach for this. We have to
these
go
things
for
are not
mathematical
really.
modeling and then we can do it.
There are two ways of doing it, but the problem is, see, if you are directly an ML engineer, if you are not really an engineer, you are just an ML engineer, okay, who doesn't know, for example, generally what is going on nowadays, ML has become a booming area. So people do not understand what is happening in the process. They just are trying to analyze the data, okay. If you are given a data set, people are trying to find out anomalies without knowing what is where the data is coming from. Okay, that is not the right approach. As researchers, what we should do is we should first we should understand the system properly, develop a mathematical model. If there is some mathematical model already existing, we should validate with respect to the system data which is coming from the system. Okay, and then we need to generate faults in the model, and the similar faults should be generated to the system, match both the system and the model information, right, in terms of outputs. And then we completely validate this. Then only you talk about ML, right? So ML comes into picture only when you are thorough with the actual system behavior. Okay. So algorithm comes last. Algorithm is a thing which comes.
I got my point actually. So
Yeah.
I wanted to find out an easy approach, but as a researcher, we'll have to go with the first system behavior and accordingly we'll have to put the algorithm. That is correct. I
Yes, exactly. Yeah. So for any system, this will work, right? So then I did not even remember what approach should be used for each system. Whatever system you are good at, you just start with it. So ML thing comes in the last.
I got it.
Yeah, thank you.
Hello, sir.
Yeah, tell me.
Sir, there the path planning algorithms is there, no? SLAM, VSLAM. It is which is this algorithms is very useful for swarm robots or collaborative robotics, sir.
See, if you understand your question properly, see, the SLAM algorithms are used by a individual robot, right? Simultaneous localization mapping. Okay. Similarly, if there are multiple robots in a network, they need to be interlocked with some kind of computing algorithm. Okay. SLAM will be running on each of the robots, and then, of course, SLAM, then obstacle avoidance, all these algorithms will be running, and then you have to find where are you, okay, at what location are you, and how many obstacles are there around you. Okay. These algorithms will help you out. You can use it for a network or a swarm of robots as well.
For swarm robot, which algorithm is very good, sir?
Generally, I don't remember the names of algorithms. So what my contention is that simple, right? So first, use a SLAM algorithm for a given robot. You have multiple robots. You have multiple SLAM algorithms. Now, what is the difference between SLAM on a single robot and multiple robots? You should have, in addition, obstacle avoidance kind of algorithm which can sense what are the robots nearby. That's all. I think then you need to integrate the SLAM algorithms with individual robots. Okay, that's what.
It's also advanced algorithm is there, sir. Visual SLAM.
So I don't remember the name of the algorithm. My approach generally is not to remember the algorithm, but to remember what to do. Okay? So I just proceed based on what to do.
Thank you.
Thank you,
sir.
Yeah.
Thank you, sir.
Yeah. Okay. Thank you.
Sir, I request our resource person, sir, and all the participants, please switch on your camera. Just we will take a screenshot.
Okay.
Sir, you first of all don't share the screen, sir, your screen.
Okay. Okay, I should stop sharing. Okay,
stop sharing. Now I request all the participants, please make attention here. Tomorrow, today's the fourth session is on the battery management in electric vehicles, delivered by esteemed resource person Dr. S. Albert Alexander, is the recipient of prestigious Raman Research Fellowship from the University Grants Commission. He is a postdoctoral research fellow for Northeastern University, Boston, Massachusetts, USA. His current research focuses on fault diagnostic systems for solar energy conversion systems and smart grids. He has 18 years of academic and research experience. He has published 92 technical papers in international and national journals and presented 70 papers at various conferences. He has completed 8 Government of India funded projects with the overall grant amount of 2.3 crores. 2 projects are ongoing that are funded by VIT and Ministry of Education under SPARK. His PhD work on the power quality earned him a national award from ISTE, and he has received 29 awards from his meritorious academic and research career, such as the Young Engineers Award from IE, Young Scientist Award from SPRERI, Gujarat, Best Researcher Award from ITP Madras Section, etc. He has also received the National Teaching Innovator Award from MHRD. He is an approved Margadarship from ACT, Government of India. He is an approved mentor for change under ATAL Innovation Mission. He is an ACT approved translator under National Education Policy to translate engineering books into regional languages. He has guided 32 graduate and postgraduate projects. 6 research scholars completed their PhD and 4 scholars are currently pursuing their PhD under his guidance. He is a member and in prestigious positions in various national and international forums. He is the chairman for ITP Power Electronics Society, ITP Madras Section. He has been an invited speaker in 300 programs covering 9 Indian states and also at USA. He has organized 13 events including faculty development programs, workshops and seminars. He completed his graduate program in Italy from Bharatiya University and his postgraduate and PhD programs from Anna University, India. Formerly, he worked as a professor in recruitment of Sri Kongu Engineering College. Presently, he is working as an associate professor grade 2 in the School of Electrical Engineering, VIT, Vellore, and also doing research work in artificial intelligence-based controllers for power conversion, smart healthcare systems, smart goods, solar PV, and power quality improvement techniques. He has authored Algorithm and Design Complexity in CRC publication, Taylor and Francis, Basic Electrical Engineering in Kanna Publishers, design and simulation of electrical machines with MATLAB in MOVA publishers, power electronic converters for electric vehicles in CRC Press, power electronic converters for solar PV systems elsewhere, advanced deep learning for engineers and scientists in Springer publications, computational paradigm techniques for enhancing electric power quality in CRC Press, and special electrical missions. Thank you, sir. Thank you for being here and sharing your knowledge to our participants. Thank you, sir, for accepting our invitation also.
Let me share my screen.
Yes, sir.
So I think my screen is visible right now.
Yes, sir. Yes, sir.
So a very warm good evening to one and all present here. Okay. So my sincere thanks to Dr. Munishankar for giving me this opportunity to have this lecture on the battery management system. Okay, so in the battery management system, we are going to talk mostly on the vehicle design and dynamics, and mostly the design perspective on this battery management system. So I'm very much thankful for every participants. Okay, and before I go into the presentation, okay, I have heard some of the queries raised by the participants in the earlier session because I joined some 5 minutes earlier to my session. I heard that two major queries, okay, because those answers may not be possible for the researchers, that is, a growing researchers, okay, to make some works in this particular domain. So I want to simplify that particular question. Okay, the two questions I will answer first. Okay, and then I will move into my presentation. In my perspective, the question number one is, okay, what is the source for data set for especially the people working in battery management system? That's a question number one. Source for data set. Whenever you are requesting any data set from any of the people, okay, they may give, they may not give. Okay. And sometimes even the mathematical modeling of a battery may not be able to work with. Then how to cook up the data set? That's a question number one. And question number two is, which algorithm is best? Okay, so that is the two major questions that sparkled me before I enter into my presentation. Let me answer those two questions, and then I will move into my presentation on battery management system with a complete review. It's all a research perspective. Okay. So whatever the work which we have done, okay, whatever the work which we are doing right now, and I will also show you some of our publications in the domain of battery management systems and also on this machine learning. Okay, so the question number one is, what are the source for the data sets? Okay, sources. Okay, so the data set, those people who is having the data set are now king. Okay, so we all know that the data is a king right now. Okay, that is the reason many people are moving with the data science, AML. Okay, so neglecting the courses like electrical, mechanical, and civil. Okay, so here the data can be obtained by 5 major methods. Okay, we have to figure it out which method is suitable for us out of the 5 methods. Okay, and I will also tell you what method I followed. Okay, so the method number one is, okay, with help of the simulation analysis. For an example, if you are working with normally I and myself and Dr. Munishankar, we are all worked with the power quality problems. Okay, so while we are working on the power quality problems, we obtain the data set through simulations. Okay, so we have modeled the entire thing. Okay, by varying either the source side or else a load side parameters variations, we have obtained the data set. Okay, so the number of data set, and there comes a question: how many data set you have to align with? Okay, there comes a question: how many data? Some people will say that I'm having a 50,000 data. Some people will say that I'm having only 50 data. Okay, now we need to compare which is best. Okay, even if you're having 50,000 data in which you are having more number of outliers. Okay, in machine learning we call the term called outliers, such a way that some data set will not contribute to your work. For an example, in your department, you are going for NBA or NAC accreditation. You are having 40 members in your department. Okay, if out of 40, only 4 people are working means, okay, then what will happen for the remaining 36? Similarly, we are having 50,000 data. Out of the 50,000 data, we have to figure it out a useful data or useless data. When you figure out the useful data, this 50,000 will even come to only 50 or less than 100. Okay, so the number of data set will not be a very big deal. Okay, with the limited data, we can do some magic with the algorithms. So the algorithm side I will come later, okay, after this data set comparison. So in the simulation analysis, either by varying the source side or the load side parameters, you can make use of a simple Excel sheet by collecting some data. So while collecting the data, we have to figure it out. What are the parameters you require? Okay. For an example, when we work on the power quality problem, okay, we work only on the variations in the voltage. We work in the variations with the current. For an example, if you work with the battery management system, what are the parameters we can take? You can take only a voltage profile or a current profile for the different loading conditions. That's all. Other than voltage and current, there is no frequency. Okay. In addition to that, you can even take some value of temperature. Other than that, what you can able, or you can able to say some kind of size, which will be the fixed parameter, whereas the voltage and current being the variable parameters. Okay, so only these parameters you can able to do. So out of these parameters, we have to figure it out which are the parameters are quite important and which are the parameters are non-important. So based upon that, you figure it out which are the input parameters or which are the output parameters. So if you are considering both input and output, we call these kind of learning mechanism are called as supervised. If you are having only the input data, based upon the input data, you have to make some kind of solution means, then it is called as unsupervised learning. Then we will talk it later. So using the simulations, we can collect the data. I have done some few works by using a simple simulation of an inverter, okay, and also a DC to DC converter. So for the simple DC to DC converter, what I did, so we are working with a high frequency transformer. We normally call the DC to DC converter that is especially using for the battery management system. Okay, the normal DC to DC converter will not help in a big picture. Normal DC to DC converter means you can go for the buck mode or a boost mode or a buck boost mode, that's all. But we normally go for, especially for the battery charging applications, if you have a review on the DC to DC converter, we normally go for the dual active bridge converter. Okay. So this dual active bridge converter will help you for the bidirectional power flow between the source to load or the load to source. Okay, but we come across many problems when you're going with a DAB, especially the design perspective. Presently, we are doing one consultancy work with one industry. So the industry is in Bangalore and also in Coimbatore. We are working with the simulation and also the design of a closed loop mechanism for a DAB controller. Okay, dual active bridge, that is from the AC mains to the complete battery charging for the closed loop. So that I will discuss at the end of my lecture about this dual active bridge converter for the bidirectional power flow. So while you are taking some simulation perspective, you will collect the data. Second one, the same experimental mini prototype. Okay, you can able to get some by wearing the whatever we done in the simulation, even the small prototype of the experimental things, we can make a collect the data. And the third one will be, as the previous session sir has mentioned about on the mathematical modeling. Okay, so mathematical modeling means you have to model the entire system. For an example, mathematical modeling is very simple for solar, very simple for wind, very simple for battery also. Okay, mathematical modeling, either you can go for the one diode or two diode system for the solar. Okay, but the thing is that by varying some parameters, so if you are going for the battery management system, you have to make an entire mathematical model. So in the mathematical model, we change some parameters. Okay, for an example, you are getting some mathematical model like x square plus y square plus 2xy means, by substituting the various values of x and y, we can able to collect the n number of parameters. That's a mathematical model. Okay, so mathematical modeling means, for an example, even when we are studying the subjects like control system, we have studied something like, that is a field control DC motor, armature control DC motor. We have made a transfer function model. Okay, so this mathematical model only is a very prerequisite whenever you are working for the works like digital twins. Okay, For digital twins, okay, it was called in the other name. That's a mathematical system only. Now it was called in the other name called digital twin. Okay, so the battery is available. You are doing some mathematical model. Whatever the changes you are interested to do with the mathematical model, you are changing. You are making with the realistic model. Okay, so that's called the digital twin. Fourth method for collecting the data will be, okay, fourth method will be on using some formulas. Okay, some formulas. Okay, for an example, when we are working with the power quality, we have worked with the Fourier transforms. Okay, that is V naught of omega t will be equal to A naught by 2 plus summation n is equal to 1 to infinity A n cos n omega t B n sin n omega t. Such kind of formulas. I used all the four methods I used, but in most of my IEEE construction paper, I have developed the formulas for my system. Okay, so through that particular formulas, I used the MathCAD software. Through the MathCAD software, I cooked up my own data. Okay, data and all, you can able to say that more than 1,500 I have not collected my data. Okay, I can prove that all my 1,500 data are perfect data because I cooked the data. Okay, I made the particular data analysis. And the last method, what I suggest for collecting the data, so you can able to visit the website called IEEE Data Port. Okay, as like a IEEE Explore, IEEE Data Port. Okay, if your data is available, you can use. So other than five methods, what many people are doing, so they will be collecting some set of data, okay, directly from the internet. Okay, so that data may be something like 500 or 5,000 data. Okay, and also the machine learning codings will also be available. So using the data, putting in the coding, and then collecting the results. That's not a right approach. So in order to make an in-depth analysis, because we can do that one, but the meanwhile we will be struggle a lot when we are going. Somebody is asking some questions related to our data, especially for power electronics, especially for the battery management system. So we can take our own battery and we can able to extract the parameters for the different set of loading or different set of charging intervals. Okay, I will explain you what are the different charging intervals in the available in the battery. Discharge is common. Charging intervals will be something different perspective. Okay, so where we can able to understand that this charging and discharging will give you a complete picture on the. Okay, so these are the various methods for collecting the data. Now I want to answer the question number 2, that is, which machine learning algorithm is best for this battery management system? Okay, so I want to list out a few basic algorithms. Okay, for an example, the first algorithm in the machine learning, let us talk across on the perceptron algorithm. It's a basic. It was developed in 1943. Okay, so this cannot be used for any complex problems because it's all a single layer network. So it will be used only for the toy level problems, to on the switch, off the switch. That's all. Okay, so we can go for some kind of back propagation algorithm. Okay, so this algorithm we can able to see that will be consisting of some inputs. We'll be having some hidden layer. Okay, we'll be having some output layer. This is called as the input, and this is called as your hidden. This is called as your output, and all the neurons will be interconnected with each other. Okay, and then we can able to get the corresponding output. Okay, we are getting some output. So for most of our power electronics problem, we go with the back propagation algorithm. So this algorithm consisting of 3 stages. Okay, so one is, that is for an example, it has to go with the feed forward from input to hidden and hidden to output. That's the first step. Second one, it will calculate the error. Okay, second step. And third step, this error will propagate backside to update the weights. This is a back propagation algorithm. So this algorithm can be used, okay, whenever you want to get some actual value in the supervised. For example, you are having some values like voltage and current. Okay, for the particular value of voltage, like 10 voltage, 6 amps. Okay, what should be the appropriate value of the output you are expecting? Let us say that you are going to control the speed of an DC motor. So, for example, you want the motor to go with the 300.5 means you can able to set this particular. For that, BPN can be used. Some people, especially for the battery management system, they are using this radial basis function networks. In a very simple, back propagation algorithm can be implemented in less than 30 minutes. Okay, and I'll tell you what are the mechanisms which we follow for implementing this algorithm. You see the radial basis function networks, it will be same like back propagation only. Let us say that it will be having the input, it is having some hidden, it is having some output, but unfortunately, This radial basis function network does not have any weight calculation between these things. There is no weight calculations. The weight calculations will be made only between these two junctions, between the hidden and the output. Here we will never call it as a hidden layer. We call that as a receptive units. So these receptive units will follow the Gaussian structure. So this Gaussian structure will be multiplied with my input parameter, and it will give some kind of function, okay, which we normally call as a nonlinear function, and that will be helpful. So normally let us talk about on the LSTM networks, okay. That is, if you're going with a time series, okay. For an example, we are not going to take any one particular data of a battery and we come to a conclusion. We will be taking some different types of intervals, like time t1 to t2 for a particular battery of a voltage parameter, v of t into differentiation of omega t. So now omega will not come, so v of t into dt. So for this particular thing, for the different average value, we can able to go for the LSTM. So the root cause for the LSTM is going to be the RBFN. So we can able to work with the RBFN or LSTM for these kind of problems. Okay, for the particular range, I can able to go with one particular major objective. That objective is called prediction. Okay, so you have to come with a conclusion that which part you are going to focus with, whether you are going to focus with a prediction or whether you're going to focus on the forecasting. Prediction is different, forecasting is different. Okay, prediction means, I want to predict, okay, that is whether the fault is available or not. Okay, using the present set of data set, present, okay, and using the past set of data set, okay, I want to predict the future. That is called machine learning. Okay, so for prediction there are some algorithms. So this we normally called as a prediction. Okay, forecasting means, okay, at present you know what is your VA rating. Okay, present, the past you know the VA rating. You can able to forecast what is the rating is required in 2030. It is called forecasting. Okay, so we can say that if your work seems to be a forecasting, there are some algorithm which deals especially with the forecasting. Okay, so that deals especially with the forecasting. Okay, so let us talk about on the, just a minute, I will come back, just a minute.
ఈ మధ్య వ్యాపారాలు బాగాలేవు, బాగా టైట్. ఆ పనిలో బిజీగా ఉన్నాను. చెప్పావు చూద్దాం బయట. నా సమస్య ఉందని చెప్పాను. ఒక స్నేహితుడిగా నాకు సహాయం చేస్తామని హైదరాబాద్ నుంచి వచ్చాను కోసం. ఈ మాస్టర్లకి ఇప్పటికీ బాగా చెప్పాలి. 10 సార్లు. అది కాదురా. ఇది కాదు చెప్పాలా? మళ్ళీ కంప్లైంట్ చేయకుండా చూసి చూడడానికి వదిలేసాను ఫాస్ట్. నువ్వు
Okay, I'm very sorry for the small interruption. Sorry, I will cope up this time limit at the end of the session. I'm very sorry. We got one urgent phone call. So here we can able to see that that is we are going for the forecasting. Or else, if you want to make some classification means, presently people are working with the support vector machines classifications. So this algorithm implementation will take less than 10 minutes. That is my overall thing. Because everybody is talking about machine learning and deep learning and everything. Okay. So these algorithms can be implemented less than 10 minutes. That is the thing. So you can able to imagine that how many papers you can able to cook up when you can able to complete the work in less than 10 minutes for the different set of algorithms. So I will once again come back with all these things because I hope I answered the two queries which was raised in the earlier sessions. Now let me move on to my presentation. Okay, so in this presentation, I'm going to deal with the introduction to electrical vehicles. Okay, so for this will take for just some kind of 5 minutes. Okay, for the general intro of the electrical vehicles towards power electronic perspective. Okay, so towards the perspective of the power electronics, I'll be talking about on the electrical vehicles, and I'm going to talk with the control mechanism of the drives, so the complete drive mechanisms, and what are the strategies we have to follow with the selection of motors for electrical vehicle applications. And then this will take just a 5 to 10 minutes, and then we are moving across to the battery management system. We are going to talk various things related to the battery and battery swapping and battery modeling and what are the requirements of battery management system, especially for the EV applications, and how to calculate the SOH and SOC and DOD, and then research opportunities, especially in the AI-enabled EV technology. So in that, I will show some of our publications, what we have done recently, and then we can able to go with the particular merits of this particular presentation. So this is the introduction, what I need to deal with. Before I go to the my presentation, I want to acknowledge my sponsors for doing the work, especially in the EV and the machine learning. My parent university, VIT, DST, UGC, ACR, ICMR, and I am the chairman for the IEEE Power Electronics Madras section. So I want to thank all these sponsors for giving my opportunity. And I want to introduce some of the textbooks which I've been done for the electrical vehicles. The first book is on the power converters for electrical vehicles, so which has been considered as a textbook for Anna University for those students who are studying the electrical vehicles. Okay, and then we have been. I have been also wrote one other book for the power converters for solar photovoltaic systems, and one book for the enhancing power quality. All the books are authored books, not an edited books. It will be called as an authored books. Okay, so these books. So today in my presentation, I'm going to speak much about on the electrical vehicles. I'm going to talk about much about on the power converters for the electrical vehicles. Okay, so with this particular thing, we can able to understand about what are the various mechanisms which will help us in order to get the uh, quite an idea. And also we have done some works related to the electrical machines using MATLAB, and also the how to specify the algorithm and the deep learning and the machine learning. So I think some interruption. Okay, fine. So here we can able to understand that one of the various things. Okay, so I just skip some of the much more theory. I want to concentrate more on the practical alone. Okay, more on the practical. So unlike the theory. Okay, so here we can able to understand that. Okay, that is because we want more number of books, because everybody know about the things related to EV, but the thing is that I just want to skip some of the things, but the major requirements, what is required, I can able to give it. Okay, so certain slides will be skipped, and certain slide I will give some importance. So here let us talk about on the steam cars. Okay, so one of the major drawbacks in the electrical vehicle we know. So as of now, I'm in my particular presentation, I'm going to take a motive on the four wheelers. Okay, so in this particular thing, the major thing will be now on the short driving range, and one of the drawback of the electrical vehicles is on the poor battery performance. Even though we are using the batteries like the lithium ion or the sodium magnesium hydride kind of batteries, so these batteries is having a poor battery performance with respect to the long driving range. Okay, so that is our motive of the today lecture. So when we talk about on the few definitions on the electrical vehicle, so why it is called as an electrical vehicle means, because it uses the electrical motors. Okay, so that is the reason it's called the name as electrical vehicle. So the battery electrical vehicle means which is powered by battery, and hybrid vehicles means which is having the both of the batteries and engines, and the plug-in vehicle which is going to plug into the grid. So here in my presentation, I also want to stress something related to grid. Okay, physically, what does the grid refers to? Okay, what are the requirements of the grid? How a grid should be? Okay, so these are some of the examples of the Chevrolet Volt and the Mitsubishi electrical vehicle. Okay, I just make a think of the electrical vehicle. I just skip. So in my textbook, I have briefed a small history. I will take just 2 minutes to explain about the brief history of electrical vehicle. Whatever we speak about the electrical vehicle at present, it was already developed more than 150 years ago. It is not a novel concept. It is not a novel idea, because whenever we publish a paper, the editors, they are expecting a novelty. Okay, but we should understand that the electrical vehicle, whatever we are projecting, it is not a novel idea. So whatever the block diagram which we speak at present, it is not a novel thing. It has already been developed more than 150 years ago. Only the novelty we can able to do, we can play only in the control side, a control algorithm or in the machine learning parameter, just to improve the performance. We are not going to develop a new thing. We are just making some improvising. Okay, that we normally called as a fundamental addition of the available knowledge. So yeah, it's an incremental addition. We are making some incremental addition of the fundamental knowledge. So this is the early history of EV, that it has been start from the British, and then it went to the first practical EV was developed in 1835. Okay, so we can able to understand it has been a history of more than 150 years, and then this is the pattern for the electrical vehicle and the lead acid battery in 1859, and then we can able to see that there are so much of practical electrical cars that has been developed even in the year of 1884, and some of the history speaks about that the first electric car in the United States was developed in 1890s. Okay, and this was seems to be the golden age of 1890s to 1900. So at that time, so even now, I can see many of the research papers which is comes to my review, because I'm in the editorial board in some of the scopus and also some IEEE transactions. So I can able to say that some of the people are even now submitting the paper on the battery swapping service stations. Even you check the Ola autos in Chennai, okay, so this exchangeable battery service was they are using it, which they call it as a battery swapping system. But you should understand that this battery swapping system, which was a old history more than 150 years. Okay, so we can able to understand that that is whatever the things we related to, that is exchangeable battery service. It's an old thing, but for the old thing, what are the additions we can able to use? That only we are going to discuss, because speaking about all the whole histories, that alone will not make a very big thing. Okay, so where we can able to understand that that is here we can able to get along with one. Okay, so what are the merits which was related to the thing. Okay, so here we can able to see this is the golden age. Okay, and we can able to see one of the advertisement even for the electrical vehicle which was released, okay, in the much more years of 1910s. Okay, so at that time the price of 35 HP. So at that time we talk about on the 35 HP, but now for the dual active bridge battery charger, we are developing something around 80 kilowatt charger, and also we are working with a 40 kilowatt charger. Okay, we can able to see that the percentage of level of this 40 kilowatt and 80 kilowatt we are doing. Okay, normally the people they are working with the small prototypes, they are working with a 3 watt, 3 kilowatt, something like that, less than 1,000 watts they are working. But the actual requirement for the battery charger, if you want to develop, it should be a 40 kilowatt or 80 kilowatt. I will also give you one sample calculations for this 40 kilowatt and the 80 kilowatt. So for the particular power rating requirement, for this power rating only we want to make use of the power electronic switches. For this power rating only we want to use this particular thing of the MOSFETs. So that is the reason the many people are shifting from the silicon switches to something like silicon carbide. Okay, why we are going for the SiC MOSFETs? Silicon MOSFETs can able to withstand the high power. That's the reason. Okay, there is no very big magic, because the power rating level is quite going high. Why the power rating level is going very high? Well, the main reason is the motor that is available over here. How to figure out this particular motor? This will be estimated by the mass of the vehicle. How to predict the mass of the vehicle? I will tell you with the help of one simple vehicle dynamic calculations. So here the electric starter was developed in 1912, and also the Henry Ford, he has came into picture, and the electric car stopped the production. And this is the small timeline history of the electrical vehicle, which was started in 1830s and dropped in 1910s. Okay, so which we normally call it as a golden time period for the electrical vehicles. But now the now comes the question that, okay, so what it will be, okay, so what it will be the need, why, how the electrical vehicle is again make this uh, revival. What made the particular thing for the revival? I will tell you. So this 1968, there has been a great car race. Okay, because we want to teach these things to our students. Okay, so such a way that the students can able to understand that what are the various things are made in the history of electrical vehicle. Because whatever we teach at present, so those things, the things related to whatever the thing. Okay, so for an example, whenever we talk about on the electrical vehicle, so here we can see that the great car race was started between the Boston to the California. So it's a cross country race only with the electrical vehicles. So it was a joint collaboration between MIT, and also we can able to see it's from the Caltech. Okay, so energy organization. Okay, between the collaboration between these two organizations. So here we can able to understand that so where we can able to see, for based upon this project was highly successful, and they've used a typical amount of the batteries and the 53 charging station, which was spaced about 16 miles, and they've reached to the Caltech. So that has been a revival for the electrical vehicle. So this is myself, when I visited the MIT for my postdoctoral research in US, I visited the places of there. They are having this particular thing related to the EV. Okay, so this revival I just skip. Now we move across to the modern electric car. Why I'm talking about the modern electric car means, I made one review. Okay, I will also show those review paper. Okay, so where you can able to see that that is what are the various mechanisms available. Okay, for an example, let's talk about on the things. That is. I made an analysis especially for the power train of electrical vehicles. For an example, let us talk about on the Tesla Motors. They developed the first electrical EV in the 2004 Tesla Roadster and delivered to the customers in 2008. Okay, so it was a legal series production of the first highway car which used the lithium-ion batteries. Okay, so which can able to travel for more than 320 kilometers per charge. Okay, that is a very important point we have to remember. But we cannot expect that for per charge we can able to expect the 320 kilometers in India, because it also depends upon the motors what we are using. It is also depends upon the various other parameters like road conditions. We will also want the particular thing like other various things. So where we can able to get that mechanism such a way that we can able to understand. Okay, so we have to understand the various kind of other parameters also, and also in Japan and also in the Germany, they have developed their own version of the electrical vehicles on the Mitsubishi and the Chevrolet Volt, such a way that so it has made some kind of production quite related to this particular thing. So here we can able to understand that this is very important thing. So that is most of the electrical vehicles that has been initiated, that has been started, they are using the lithium ion. Okay, so and I made some analysis that what kind of battery management system that they are being doing in these kind of EVs. Okay, what is the battery management system? Battery management system, it seems to be a very small part in the electric vehicle analysis. Okay, because battery management system is just like a human body. Okay, so as a human body, you are eating some food. Okay, and you are doing your day-to-day activities, but we don't know that what kind of changes that has been occurring in the internal organs of our body. Nobody knows. Okay, only if some problem comes, only they will say, and they will check the liver, they will check the lungs and something like that. But the same thing happens for the battery also. The battery is given to the particular level of input, we normally call it the food. The food like a voltage and current we are giving as a food to the particular battery, and then it discharges, charging and discharging, it is happening. But internally what is happening, what kind of physical phenomena, what is the chemical reaction that has been taking internally, nobody knows. Okay, that is it's like a chemical. So for that, we are also trying to develop a chemical reaction based. It is just like a thermal scanner only, but a thermal scanner you can able to see only the heat and the cold with the different color parameters using a thermal scanner. But we want to develop a mechanism such a way that we want to visualize the chemical reactions what is being taking place inside the battery to visualize outside. Okay, if anybody interested in this area, you can please contact us. Okay, we are working because this is not a this cannot be done within a day. It will take some years to understand that because if it is success for a battery, the same thing you can also implement for the human body also. We can able to predict that what is happening with the inside of the body the regular basis. Okay, so that the people can able to understand that what kind of food, whether it is okay for them, why they are getting some pain, what health they can able to do that. So initially, I am considering only for the battery. Okay, so for the battery, we can able to play with a different kind of mechanism. So we are going to give more number of research avenues and the research kind of things over here. So here, let us talk about on the simple vehicle dynamics of a car. Okay, for an example, what is the motive of this explanation means, so the major motive of the explanation is going to be, okay, that is, I want to show you to the people that is okay, what is the power rating you have to design for a vehicle. Okay. For an example, you can work with anything in the MATLAB or you can able to develop for your electrical vehicle. But the thing is that, so where we can able to get, okay, so what are the mechanisms which, so it is consisting of only a very simple formulas. Okay, for when you are talking about on the vehicle dynamics, so if you surf in the internet, you can able to see n number of textbooks are available for this vehicle, especially for the vehicle dynamics. So for the even for the people those who are studying in the automobile engineering, this is the basic course. Okay, is if anybody is quite understand quite interested means I will be giving you a detailed book. Okay, so that was written in the basic English, especially for the I can say diploma level automobile students. So where they can able to study the step by step of the various parameters. So here, let us talk about on the two axle vehicle component. Okay, so I want to calculate. So we have to follow the mechanism what we have followed for the windmill. Okay, so let us talk about on the windmill. So let us say the 3-blade system or the 2-blade system. If I want to calculate the energy of a windmill, what I have to do? I have to say whether the windmill works on the kinetic energy or the potential energy. Okay, so it basically works with the kinetic energy. So I have to substitute the formula as half into m into v square. Okay, so there is no mass available. So what I have to do? I have to substitute mass is equal to rho into v. Already the v square is available. So total energy will be equal to half into rho into v cube into area. So this is a total energy what you can able to predict. Okay, so based upon that you can able to calculate the power rating and you can also calculate. So if you are having the energy requirement, you can able to calculate the what is the area required, what is the air density, because air density is a common for the particular area. Based upon that we can also measure what is the velocity requirement for the windmill. So here let us talk about on the perspective of the electrical vehicle. So here, we have done some papers. Okay, even if you're interested to design a vehicle charger, your paper writing should be start especially with the vehicle dynamics to show what is the power rating you are taking. So some of my students they have taken with a small tractor. Okay, beginning level, they have taken a tractor. They made the calculations. What I will show you one model calculation. This is a model calculation. I will explain. So for the simple tractor, they made the model calculation. For the model calculation, they got some power rating. For that power rating, they designed the motor, they designed the charger, and they published the thing. And some cases, I will also show one of the paper where we have done for the things like school bus. Okay, and some people they are also working with a truck. Okay, so they were working with a truck. So we can able to cook up more number of papers, especially in the electrical vehicle. Okay, so we can start our paper from the vehicle dynamics and we can end with the policies and the infrastructure requirement for powering these kind of higher requirements. So now let us talk about on the same electrical vehicle. Let us say that your vehicle is moving in in this direction. Let us say that seems to be your window, okay, and we can able to say that there we have to check what are the forces acting place. Okay, so this is the force number one. Okay, so this formula is taking place as following with the windmill. Okay, so this is also the formula like half mv square only, a kinetic energy. So instead of m, we are substituting rho a and cd. Okay, so d is that cd refers to diffusion coefficient. Okay, so we can able to understand that we are talking about some cd, crr, and some kind of coefficients. Okay, so where we can able to understand that cd, okay, or crr. Okay, so these are the coefficients. The different level of coefficient. Okay, so where we can able to understand the various things. So we can able to understand about the vehicle dynamics. Okay, so for the CG and CRR and various other parameters also. So in this particular perspective, as I already mentioned you, this is the kinetic energy. So half mv square, so mass I'm substituting with the rho into a into cd, and this v here v refers to the speed. Okay, so there are two speeds are acting place. One will be called as the actual speed of the vehicle, and what is the opposite speed we called as a VW. So why we are putting this square? Because of mv square. So this is called as the one force. It is acting in this direction. And second force, we can able to say that it is called as the mg sin theta. So this mg sin theta means m refers to the mass of the whole vehicle. So we have to understand that whenever we are working with a vehicle, so we have to understand what is the value of the mass, overall the weight of the vehicle. Okay, I will tell you one small sample calculation. Okay, which we have done for the normal vehicle. And g refers to the gravity, and theta refers to the angle of the vehicle. So you can able to see even for the different value of theta, you can able to write on research paper. Different value of theta. What does the theta refers to? Theta refers to, you can able to see this is the value of theta. That means I am making the vehicle, it is moving upwards to the hill. Okay, it is moving upwards to the hill. Okay, so for example, if the theta is equal to 0 means we can able to understand the vehicle is going in, because the theta is equal to 0. There is no theta. Theta is equal to 0. So by varying the different level of theta higher, I can able to get the different values of theta. So whenever we are making for the overall power calculation, it will be governed by what is the maximum level of theta, because theta means you are making some higher amount of propulsion when the theta is greater than 0 degree. Okay, normally in the vehicle we have to make some ample amount of theta degree, so such a way that, so initially for the vehicle calculation, let us assume that we are talking with a 0 theta is equal to 0 degree. So whenever I am taking the subject for my students while giving the problems for the electrical vehicle, I will be giving some kind of CD is equal to some value, CRR is equal to some value, mass of the vehicle is equal to some kind of 500 kg or 1000 kg, okay, and gravity they have to assume. So based upon that, they have to come with the conclusion that what is the power requirement for this electrical vehicle. Okay, so one is called as mg sin theta, and one is called as mg cos theta. Okay, sin theta and cos theta. Mg refers to the mass into gravity. And the force, this is the force number 1, this is the force number 2, and one more force that is acting opposite to the vehicle dynamics is called as mg crr cos theta. Okay, so RR stands for the wheel rolling resistance. Okay, so this is called a diffusion, this is called as a rolling resistance, and these are the three forces acting in the opposite direction. One force is acting towards the movement of the car. That force is called Ft. What is meant by Ft? Ft is called as a traction force. Traction force. Because once you know the value of the motor only, if you know the value of the motor, then only you can able to design the value of the battery. So as like the mini projects, we cannot be able to come to conclusion that our battery is going to be something like a 12 volt 100 Ah, something kind of thing. So no, that is wrong. Okay, so we have to decide what it will be or various things. Okay, so we can able to understand that these are the various aspects quite related to the design of a power rating. Then only we can decide the force. Okay, now we are going to take a force balance equation. Okay, this force balance equation will be given by m alpha. Okay, so we can able to see that alpha, initially I'm going to take it as a 0. Theta is different. Alpha will be normally called as a diffusion coefficient angle. Okay, so the theta will be this particular theta. Alpha means what what is the variation of the angle between the subsequent forces. Okay, so the force balance equation of any vehicle will be given by m alpha is equal to ft minus summation of total forces. Okay, summation of the total resistive forces. Fr, see, Fr stands for resistive forces. T stands for the traction or the propulsion force. So I want to calculate, there are, as I said, there are three forces are acting for the resistive force, which was acting in opposite to the movement of the car. Okay, when the car is moving this side, there are three forces acting in the opposite. This is the force number one, this is the force number two, this is the force number three. So I want to add all the three forces. That is the reason I'm giving it a summation of the total resistive force. Now I want to calculate the Ft. How to calculate the value of Ft? So Ft, by this force balance equation, I can write that Ft will be equal to m alpha plus summation of Fr. So this equation I'm writing for Ft, because Ft means, I want to calculate the total traction force or total propulsion force. So F alpha, Ft will be given by m alpha. So m alpha is given plus summation of Fr. Summation of Fr will be the total three forces. Fine. Now I got the total propulsion force equation I got, but I want the power equation I need. So power equation will be given by what is the total propulsion force multiplied by your speed of the vehicle. So V stands for speed, not voltage. It speaks about the speed of the vehicle. So I want for each and every parameter m alpha into V, mg crr cos theta into V, and for this kinetic energy equation is multiplied by V, and mg sin theta into V. Okay, so this red color equation is required, okay, in order to calculate the force. Whenever you are writing a paper for any kind of vehicle, we have to include this equation in our paper to make the people to understand that why you have taken a 40 kilowatt rating or 80 kilowatt rating of a vehicle. Okay, so for this I made one simple calculation, but anyway I will share this particular presentation to Munishankar sir, so he will be giving to you. Okay, so where you can able to see that we have taken a sample calculation of a mass is equal to 1000 kg, and let us say that speed is equal to 100 km per hour. This is our requirement. So as I already mentioned, the power equation is equal to what is your Ft into your speed. So this is the equation what I shown in the previous slide. So I want to substitute mass is equal to 1000. Okay, and alpha is equal to 0. Okay, so for an example, if you are having some vehicle dynamics data, if you are having some alpha, you can able to substitute the alpha value also. If you are substituting the alpha, what will happen? Some 1 kilowatt will be added. For an example, let us say that if you are taking some alpha value between 0 to 1. For an example, if you are taking the alpha is equal to 1, what will happen? 31 kilowatt will now become 31 plus 1, it will become 32 kilowatt. That's all. And then m stands for your mass, and gravity is given by 9.81. Okay, a normal gravity, and CRR is a constant 0.02 cos theta. Okay, so cos theta means, so I've taken the theta is equal to 0, cos 0 is equal to 1, so I've not included, and 1 by 2 is given by 0.5. Okay, and rho is equal to air density is equal to 1.2 into kg per meter cube, and that is I want to calculate the different set of the value, that is what is the area. Okay, so area here the area is given by 2 meters square. It's a window area. So as per your vehicle design, if you want to vary the area of the vehicle, the front end area, you can able to give it, and the diffusion coefficient, and what is V minus VW. Okay, so here the speed is given by 100 km per hour. So this 100 km per hour, what I'm going to do, okay, so this 100 km per hour, I want to convert to meters per second, because this equations I want to talk about with meters per second. So how you will convert this 100 km per hour into meters per second? You have to multiply by 5 by 18. Okay, that will give you the meters per second. So this answer will be given by, so you will get 0.27. So multiplied by 100, you will be get the answer as 27.7. So I am giving you as a 28. Okay, so I am considering the speed of the vehicle is equal to 100 km, and the operant speed VW is I am taken assumed as a 0. So 100 km per hour minus the 0. So this 100 km per hour I converted to meters per second. It will be 100 will be converted as a 28. And then mg. So m is equal to 1000, g is equal to gravity, sin theta. So theta is equal to 0. So sin 0 is equal to 0. So I'm not going to include this particular term for the force balance equation. And again this V. So this equation is enough to calculate what is the power requirement. Okay, so the total power requirement for your vehicle, power requirement for the propulsion is equal to 31. Okay, so like this only, not only I have given the expression for the normal vehicle. Okay, so if you want to make this particular thing, let us say that, so for an example, if you want to go with a different set of vehicle, you assume some parameters. Okay, for that assumption you have to calculate. Okay, I will tell you, because you can ask me a question, sir, you have given me the values of 31 kilowatt, or 30 kilowatt, or 32 kilowatt, or 40 kilowatt. Okay, how you can able to prove it that these kind of values only the vehicles are having? I will prove it very soon. For an example, this is the total power rating of your vehicle. For an example, if you are having some additional requirement for the vehicle, the additional requirement is you have to accelerate your vehicle from 0 to 100 kilometer per hour in the initial 10 seconds. Okay, so for that, what you have to do, you have to take the mass as 1000 kg and also 28. Okay, so divided by this 10 seconds, so 28 divided by 2. Okay, and also the 0 to 100 kilometers, and again this 100 kilometer per hour, I'm going to convert so the into meters per second, and then divide by this particular 10. I will be getting the value as 2.8 or 2.7. I'm getting the value as 38. So now what will happen? This is the additional requirement. If you want, you can go, or else you can stop your calculation up to 31. So this is the initial requirement, such a way that, so I'm going to multiply only the available parameters of mass is multiplied with my speed by 2, okay, half of the speed, and then I want to make the initial requirement of this particular thing, that is 10 seconds, that is the 2.8 divided by 10, so I'm going to make a 2.7. Okay, so whatever the requirements we are giving, we are going to make that. So 31 plus 38, I am getting the 69. So totally, I want to design my EV for 70 kilowatt. Okay, I will prove that how the calculations are seems to be right for the different set of vehicles. Let me skip these things. Let us say that I have taken some kind of comparisons with the other set of vehicles. See, I'm not here explaining how the electrical vehicle works, because everybody knows. Okay, even school-going children, everybody knows that how the electrical vehicle works. But here, as a research paper or researchers, what are the works? What unlimited works are available over here. I will also showcase some of the works what we are doing at present, because we are having only 30 more minutes. Okay, so within this particular time, I want to give maximum number of inputs. So whenever you take a Nissan Leaf, it's one of the vehicle. I will take an analysis only for the powertrain. Powertrain means which are the power. Why it is called as a powertrain? Train is not a word which is given for our normal loco train or a passenger train. Train is connection of components is called as train. That's all. Powertrain means how the power transfer is taking place within the electrical vehicle. So this powertrain consisting of electrical motor. Okay, we normally have electrical motor. Transmission, how the force, there's a mechanical force from the motor which will be given to the wheel through this transmission. So for example, you're having a motor over here, how the force is directed for these two wheels and also the wheels. This is called as a transmission line, okay, as like a power transmission line. And similarly, a battery. And there are different type of ranges and what are the plug-in charging. So here you can able to understand. Let us talk about the Nissan Leaf. The value, the electrical motor rating, that's for the propulsion, they're using a 80 kilowatt. So at present we are designing electrical vehicle charger for the industry. So they have requested to make it for 80 kilowatt because of this motor especially 80 kilowatt. Similarly, the battery. Okay, the battery which will be helpful for charging this particular thing, it has been given by 24 kWh or 30 kWh. Then it depends upon the different varieties or different models. Okay, and then the range. Okay, so what are the different range for estimated power agency, EPA or NEDC? These are some of the standards. So for the single charge, how much of kilometers it can able to travel. Okay, and also plug-in charging, the different sockets. I will also give you some inputs related to what are the different research which we have done, especially the charging sockets, just with the help of sockets. So I can refer many people. You can do some work in electrical motors, transmission only limited works, battery n number of works, and the range calculation n number of works, and especially the charging sockets. Okay, optimal choice of sockets. Okay, especially the chargers is required for charging this. So other than transmission, we can able to do n number of works. So here I have not included the power electronic converter at the middle. I have not included the power electronic converter because more number of works have been done with the power electronic converter. So we can able to focus much of the thing to improve the performance of these vehicles. So let us talk about on Ford Focus. So we can able to see that this motor is about 107 kilowatt. Okay, so and a synchronous motor, and the battery is about 33.5 kWh. Let us talk about on the BMW i3. So because we know that the electrical vehicle, it replaces the engine with the motor, but we take about the BMW i3, it has both the features, both engine is also there, electric motor is also there. So we target only at the electrical motor. We can see we have to design the battery charging infrastructure for 125 kilowatt. And similarly for the Chevrolet Volt. Okay. So Chevrolet Volt is a permanent magnet motor, and also the battery is about all the batteries are lithium ion. Let us talk about the Tesla S grade vehicle. So here the motor what they are using is three-phase AC induction motor. For example, whenever you are teaching the subject like machines 2 or AC machines, you can just to show the first slide that the Tesla S they are using a three-phase AC induction motor, and we can also say that what the total power rating of this motor is about 581 kilowatt. Okay, we can able to see that is the reason. Okay, the price with help of this comparison, what we can able to understand, you can able to see that what is the variation of kilowatt between all these vehicles, and we can able to make this analysis with this price comparison. Price comparison means, so what is the total rating? So for example, if this vehicle is having the better good performance means, so which makes this vehicle to be high perform? Because it's a high perform three-phase induction motor, and also the rating is a 581, and also the battery is about 100 kWh, like that, all are lithium ion, and also plug-in charging, and consisting of onboard charger and outboard charger, supercharger is available. So these are the additional features that's been available in order to make this vehicle as quite outstanding when compared to the other vehicles. That's the thing, because the investment for the motor is more for this particular type of machines. And Mitsubishi EV, it is having a 47 kilowatt electrical motor, for the propulsion. So these things I just skip the design of the vehicles. And what are the objectives of the electrical vehicle? I just skip those basic theory. Okay. So there are the two different types of charging modes, especially for the battery is concerned. We normally talk the comparative analysis between the slow charging and the fast charging. Okay, slow charging means always we talk about on the AC charging pile, or it is called as onboard charging. It's always called as a slow charging. So fast charging means we are moving across a DC charging. DC charger is a fast charging when compared to AC charging pile. Okay, so fast charging means it can able to charge within 30 minutes to 2 hours. Okay, whereas a slow charging means the same kind of vehicle, it can able to go with a 10 hours, 6 to 10 hours. Infrastructure cost for the DC charging is obviously high because we are going with a multiple comparison. Whereas AC charging pile, the infrastructure cost is very low because directly from the grid, by making some kind of increasing or decreasing, or by making the troubleshooting, or by reducing the harmonics, you can able to directly charge the vehicle. So infrastructure cost is low. So the impact on battery life for the fast charging is comparatively large impact. Okay, so the major impact, because the batteries also seems to be is a DC component. So the impact on the battery life will be large. Okay, so whenever nowadays many people are focused only on the fast charging, because fast charging, DC charging, and everything. But the impact of the fast charging on the battery will be very large. That means especially life of the battery. Okay, that's what we talk about on the battery management system, especially for the DC charging mechanisms. So the DC charging mechanism, we talk about on how this particular thing, it makes essential things related to this particular thing. Whereas the impact on battery life for the AC charging is quite less. So this battery swapping, I just skip because it does not have the thing. So the previous session, I can also hear some of the questions related to energy storage systems. Okay. So normally I have made some kind of review for the energy storage systems. especially for the batteries. Okay. So what are the major batteries and ultra capacitor flywheels? Okay. So normally we have to understand the difference between these kind of elements. Electric vehicle is concerned, we talk only about the batteries. Sometimes we talk about the ultra capacitor, which is also called as super capacitor. We cannot say that ultra capacitor or the super capacitor are going to be an alternate for battery. No, that is wrong concept. Okay, we cannot neglect the battery and we can able to use the ultra capacitor. Ultra capacitor role is limited such a way that it can be used for three major process. One is whenever you want to have a initial pull. For an example, when your vehicle is heavy loaded, you need an initial torque, high torque to be given. At that time, the battery cannot have because it's having a specific energy capacity will be there, and the power capacity is there, but the energy capacity is very less in the battery. So what will happen? These ultra capacitors are very much used whenever you're having a high pulling torque at the initial excitation. That's the first one. Second one is ultra capacitors highly used whenever you're driving towards the hilly areas. So for the hilly areas, the theta level is going to be very high. For that particular thing, the battery power may not be sufficient for pulling your vehicle to the upward hill. So for that particular thing, we can go for the ultra capacitors. So when we talk about the energy storage system classification, even I can ask some people, you can even write a review paper, or else even you can write a work paper related to the different comparison analysis of the energy storage systems. For an example, for the EVs concerned, we always start with the electrochemical batteries. So these electrochemical batteries are classified into two. One is called classical batteries and the flow batteries. Okay. So classical batteries, we follow only the lithium-ion batteries for the electrical vehicle, or nickel magnesium hydride batteries, or sodium ion batteries, or lithium sulfide batteries. Okay. Or some cases, earlier cases, lead acid battery, or lithium polymer battery, or sodium nickel chloride, or nickel fluoride battery, or vanadium redox oxide, or the zinc and bromine battery. These are called flow batteries. For example, many times school students, whenever I'm taking some classes for a school student, they will ask me the question, uncle, you are saying that, that is, there are some satellites are moving across our globe, the universe. What batteries they are using? Why don't we use those batteries that are useful in the space for our ground level EV requirements in order to increase the life durability of the batteries? Okay. So whenever I usually think about those kind of things, because the batteries, whichever we're using in the space stations, okay, because it should have the long shelf life, and also it has to tackle those kind of environments. Okay. So normally the vanadium batteries and also zinc bromide batteries are also, we talk about many kind of batteries. There is one separate book is there for, especially for handbook of batteries. It is easily downloadable in the Google itself. Okay, it's open source book only. So where you can able to see it, because that book anybody can write, because it is a combination of the different things. Okay, because we should understand how the battery works. Battery works especially on the two major actions. One is called reduction, one is called oxidation. Reduction means it reduces an oxygen atom. Oxidation means it gains one thing. Reduction, oxidation. Okay, for the charging, for the discharging, oxidation, reduction. So I want one person to do this reduction. I want one person to do this oxidation. So the person who is responsible to do this reduction and oxidation, they are called as anode and cathode. Okay, so these anode and cathode only will be helpful for me such a way that, so this anode and cathode will helpful for me to go for the two actions for reduction and oxidation, because as I say that charging and discharging compress of reduction oxidation and the reverse process oxidation reduction. That's all. So the total charge balance equation of any battery will be comprising of that comprising equation of two things. One is on the charging cycle equation and the discharging cycle equation. That will give the balance equation of the any batteries. Okay, so here you can able to see we always target about the electrochemical batteries. Many people will ask a question, why not we can using the other set of batteries that comes under the thermal category, mechanical category, electrical category, chemical category. We can use all these things, but it requires some additional subcomponents. For an example, if you take a flywheel, in order for the rotation of the wheels, I need to produce some kind of additional external wind. Okay, so that cannot be make a possibility for me. For an example, I can go for the compressed storage of liquid air. So for that, I need to have some kind of adiabatic or a diabatic process to be done for making the compressed air. So this battery will be a normal solution. So where we can able to see that that is the combination of the chemicals. So to overcome the chemicals, only the people they are going with the super capacitors. It is a combination of the battery and the capacitor. That's all. Super capacitor is a combination. So as we studying about IGBT, what is IGBT? IGBT is a combination of the BJT and the MOSFET. Okay, it takes some good qualities from MOSFET, good qualities from BJT, and combine. That's called IGBT. Similarly, super capacitor it takes some good qualities from the battery, it takes some good qualities from the capacitor. Combine these two. That's called super capacitor. So these are some of the challenges. So here in the battery management, I need to say some of the challenges, research problems, especially the battery management system. That is, I want to have some accurate techniques to determine the battery state of charge. Accurate technique. At present, in your battery, in your laptop, in your mobile phone, we are having the state of charge. Okay, so state of charge means what? What is the percentage you are seeing in your battery? So in your mobile phone, you can say that the charge available at present. Okay, so the charge available at present, so that is going to be so charge available at present. That seems to be the state of charge. Okay, so that we can able to see how these mobile phones can able to see the percentage, how the laptop can able to see the percentage. Why can't in the normal UPS we cannot able to see what is the amount of percentages are available? Okay, because here we are taking across the liquid electrolyte, whereas in the mobile phone and the laptop we are taking about the solid electrolyte. Okay, then what makes the sense or what makes the difference to show the state of charge? State of charge means what major thing, what I was interested to tell you. You forget about the discharging profile. Discharging means, depending upon the load, the discharging profile, even with the help of the MATLAB, you can able to assess the discharging profile. For example, for the different values of current, when you're plotting in the MATLAB, you can able to get the discharging profiles like this. So discharging is depending upon the type of loads, whatever you are using, and then based upon the profile. But when you talk about on the charging, this charging is a very important phenomena. Okay, that is, I want to determine the battery state of charge, especially during the charging of the battery, because I need to know, because charging is very important. Because in the vehicle, I was waiting for the vehicle charging station. It has to be charged, but you should understand that this charging comprises of three major processes. Okay. The charging cycle comprises of three major processes. One is called as a bulk stage, one is called as absorption stage, one is called as a float stage. This is called as this is the mechanism. For example, I'm doing some works on microgrid. Okay, so in this microgrid, I'm having an equipment called battery gauge. Okay, so this battery gauge, whenever you attach a battery, it will show you what it is the bulk voltage VB, what is the absorption voltage VA, what is the float voltage VF. So this is the very important parameter to assess what is the state of the battery. Okay, for example, if you want to develop a fast charger, okay, how will you develop the fast charger? Time. So you have to understand the charging time comprises of three different time intervals. One is the bulk time, one is the absorption time, one is the float time. You can able to see the total time will be equal to TB plus TA plus TF. Three times. So we want to know what is happening in the bulk stage. In the bulk stage, let us say the phasor diagram of the voltage and current, okay, which is shown the green and the red color. During the bulk stage, we can able to see the voltage is also increasing and the current is also increasing over the particular time. Okay, so the batteries, it draws the maximum current in the bulk stage. So that is the reason whenever you are charging a battery from 0% to, let us say, some 75%, it charges very fast, because you can able to see the voltage and the current phasor are increasing wise. And after that time, the voltage is maintained a constant. Okay, so at that time we can able to see that the current drops to a minute. So whenever you take your mobile phone charging from 75% to, let us say, 85%, it takes more time than the time what it has been taken for the TB. And after that thing, after completing the absorption, it goes to the float stage. In the float stage, both voltage is also reduction and current is also reducing drastically. Okay, and then we can able to see the floating current will be more. So this combination of these three things is called as the one complete charging. Whenever you are going to complete that, you are going to charge from 0% to, let us talk about on this particular thing like 100%, it has to travel the bulk stage and absorption stage and growth stage. So with the help of machine learning, okay, even you can able to acquire these parameters, and you can able to predict what kind of charging levels and what kind of charging mechanisms which we can able to focus in this particular domain. It's quite interesting. So now I can able to show that, so these are the different versions I can do. And another important challenges of the battery is, this is the work what I'm doing at present. This is the work what I'm doing at the present. Earlier, we have done some works related to determine the battery state of charge. This work I'm doing at present, that is developing the abuse tolerant batteries. Okay, so which I normally call it as a self healing batteries. Okay, that is I call it as abuse tolerant. What is meant by abuse? Abuse means it is a disturbance. Okay, for an example, let us take you are having a battery, you are making some kind of disturbance. Even with help of disturbance, how you are going to make a battery to operate, that is called develop abuse tolerant batteries. So for that, we are using power electronic actuators and then some sensors and a closed loop mechanism to visualize that which are the elements that abusing the battery, and how I can able to prevent the battery from this abusing conditions. Okay, so that is called as abuse tolerant batteries. And finally, recyclability of batteries. Okay, if you have time, or if you're visiting IIT Madras, so they are having a Center for Battery Energy and CBEEV. You can just put in a Google. Okay, CBEEV. So its office is also located in Hyderabad. Also CBEEV. So Center for Battery and Battery Energy and Electrical Vehicles. So recyclability means what is the available battery, they are taking some components and they are taking the that is they are keeping the faulted batteries, or the battery that has been that has been completed their life cycle. They are taking the battery and analyzing and taking away the individual components. Okay, so like anodic components and cathodic components and the separator, salt separator, and also the other kind of some plastic components and everything, and which other things can be reusable, they are working on to that. So these are some of the challenges, especially in the battery management systems. So I can say with the directly, so some kind of definitions. So these are some of the batteries that has been used in the electrical vehicle, especially with the different models. Let us talk about the lithium ion and the nickel magnesium nitrate. So I just move across some certain definitions of the battery before we are going with the typical works what we have done. Okay, so this particular battery, it has been initially the battery consisting of cell, it has been consisting of modules, and the total pack only we are calling as a battery. Okay, and the battery is having a two different rating. One is called voltage, that we all know, and ampere hour. Ampere hour means, let us take about 100 Ah battery, and then how this ampere is delivered to the load, that is called the 100 Ah. Okay, so how it can be discharged from a fully charged under specific conditions, and then specific energy and specific power, or else are defined with the help of the what is depending upon the size of the battery, we call it as a unit mass. And then energy density, power density can be calculated by whatever by current, watts per current. And we normally talk about on the internal resistance of the battery. So this will take place a major role while we are plotting the mathematical modeling of the battery. Okay, so this internal resistance is quite changing for both the charging and also discharging intervals, and also it changes for the various operating conditions. So whenever we are making a mathematical modeling of the battery, so this internal resistance, it should be a variable parameter that is variable resistance, such a way that for the charging and discharging it has to get varied. Let us talk about on the peak power of a battery. According to the definition given by US Advanced Battery Consortium, the power will be equal to 2 into open circuit voltage square divided by 9 into R. Okay, so this will give you the actually open circuit voltage will be the maximum voltage what the battery can withstand, not the peak voltage. We will be normally talking about the open circuit. Even if you are drawing the characteristics of a solar PV, similarly like a battery, open circuit voltage seems to be the maximum voltage. Okay, then only the peak voltage will come. Okay, this seems to be the voltage. X-axis, open circuit voltage is the maximum. Then only the peak voltage. Okay, then after this is normally short circuit current. And seems to be the cutoff voltage. Actually, this cutoff voltage, we have to make a note while you are designing this battery chargers. Actually, this cutoff voltage is usually defined by the manufacturer. Okay, so that is says that it is cutoff voltage is interpreted as an empty state of charge. For an example, some people even they say that even their battery says the state of charge is equal to 1% or 2%. In spite of that, the battery is functioning well. The mobile phone is functioning well because according to us it is 1%, but according to the manufacturer it is not 1%. Even some level is available, something like a 4 volt or 5 volt are remaining available. It is only to safeguard the battery. It will be set by they can able to talk because that is not a cutoff voltage. Cutoff voltage will be then set by the manufacturer. Okay. So state of charge can be calculated by what is the remaining capacity of the battery divided by the rated capacity of the battery. Okay. So that even in your mobile phones, what is the thing which we are going to see? Okay. That is, if you are seeing the 60% in your mobile phone, you can say that 60% of charge is the remaining capacity of the battery. Okay. So this we cannot say the 60%. We can make use of all the 60% subject to some conditions like a load current and temperature. So whatever we are seeing in your laptop, whatever you are seeing in your mobile phone, that is called as a state of charge. Depth of discharge means what are the actual charge that has been already used and been discharged. So 60% remaining in your mobile phone means 40% you have been already discharged. So that is called DOD. So DOD can be calculated by 1 minus 60, which will be called as your 40. Okay, so we can able to understand that state of health. This is my present work, what I'm doing. So this is state of health can be defined as what is your aged capacity of your battery, what is the rated capacity. So rated capacity of your battery can be given by 12 volt battery, 110 Ah. Okay, for an example, if you're taking a aged battery, you are going to measure the energy. Energy means you are going to take the V and also A and H. That is called as the energy. So you are going to divide with these two parameters, and based upon that, we can able to calculate the SOH. Okay, so it does not mean that it will be giving the rated value of 12 volt or 110 AH by checking that one. And number of cycles is given by total number of cycles given for charging and discharging cycles. Okay, so for certain battery they have been designed for 5,000 cycles. Certain battery were designed for the 3,000 cycles. When the cycles are completed, that's all. The battery life has been gone. Okay, that's a normal thing. We call it a cycle life. This we already discussed, the charge profile. Let us talk about the EV charging schemes. There are various schemes. Okay, so normally the charging level are classified into three types. One is called level 1 charging, level 2 charging, and level 3 charging. So presently we are working with the level 3 charging for the industry, which is about the 40 kilowatt rating. Okay, so level 1 charging means it will be a 3 kilowatt. That is mean for the two-wheelers. Okay, so where the motor capacity is very less. And also the level 2 charging will be based upon the total that this power calculation only we have discussed earlier. Okay, so based upon the power calculation, we have to decide what is the level of the charging we are going to use. Based upon that, the charging level can be classified into level 1, level 2, and level 3. And this I just skipped for the vehicle to grid technology. Okay, and these are some of the EVs that has been present today. Okay, now I can be able to move across to the another set of thing. Okay, that is okay. So where I will be showing some of the publications recently. Many are available in EV. I will show some of the publications what we have done recently on this electrical vehicle. So this is one of the publication. Okay, so it's a comprehensive assessment of electrical vehicle development, deployment, and policy initiatives to reduce greenhouse gas emissions. What are the opportunities and challenges? Okay, so one thing you can able to see. Okay, that is this certain things it will happen. Okay, some journal articles you can see. So it was received in April, accepted in May, published in May. Okay, so now it is not possible. Now it takes much more time. Okay, I'm just making a small note to make the people to get understand. Certain papers when it was done. Okay, because it's a full length paper. Okay, I will also show you how the received and the acceptance was made within a month. Within a month. Okay, so they have received on April 2 and accepted on May 12. That's within a month and published on the May 16. So within the 1.5 months, everything process have been done. Okay, so here you can able to see in this particular paper we have discussed about what are the various challenges and what are the policies. So we have taken a review on different policies for the various countries. Okay, so related to the vehicle performance. So we have taken the capital running cost of most countries. Okay, so this is a review paper where we have divided among the authors about the various topics, and we have taken this particular paper. That is, one person has taken for the China-based vehicles, one has taken for US-based vehicles, and we made a complete analysis and what are the specifications and power transfer models and what are the different charging mechanisms. And here this table will give you the what are the EV battery specifications and the charging requirement for the AC charging and DC charging, and what are the model of the vehicles for the different countries. Okay, so this will be taken what are the different standards for the charging techniques, different standards for the IEC standards. Okay, and then we also made some related challenges for the batteries, the charging standards. And this is what I want to discuss, So charging terminals, okay, what are the different terminals, such a way that the different kinds of electrical vehicles they have been using, okay, how the sockets look like, how the connectors inlet look like, okay. And this is what the government policies for the electrical vehicle. We have taken the policies given by China, US, and also the Japan, okay, and also India. We have taken, and also we made some findings, and finally we concluded this particular thing. So here, this paper does not have any work. Okay, we made a comprehensive review on the different aspects. I will show one of the paper which that has been published in IET, that is electrical systems in transportation. So here, as I already mentioned, that is how to develop a paper by making some vehicle dynamics. So here we have made a vehicle dynamics for the EV in the college campus. Okay, so we have taken one college campus as a reference. Okay, so for this particular college campus, okay, how we have taken one vehicle dynamics. Okay, so for this particular vehicle dynamics, a complete thing of EV based system. So we have developed this particular thing. Okay, and again we have taken one IEEE transactions on this energy conversion. So here we have worked with the abuse tolerant batteries. Okay, so this we have used a deep learning method. Okay, I will show the deep learning. So this is a deep learning method. Okay, so we have used two different hidden layers, which will be considering as a deep learning network, typically input and output layers. Okay, and we have made a corresponding analysis such a way that how even with the fault environment, how this particular system will work. So we have taken one appendix such a way that we have taken the different solar faults and more especially inverter faults, and finally we have also taken across the battery faults also. So in the battery, how the fault we have analyzed, how we have tested for the similar kind of things. Okay, so how we have initiated this overcharging means battery can be affected by two means. Okay, one is called overcharging, one is called over discharging. Overcharging means even if the battery is charged 100%, even after that you are charging the battery means that is it is called as a overcharging. Okay, so overcharging, over discharging means even if it reaches this 0%, it is discharge completely. Even it reaches the cutoff voltage, also it discharges means that is the way how you are going to damage the particular kind of battery. And then we have also made some kind of one more paper on the IET. Okay, so here we have made an analysis of the windings for the hyper reluctance motor for the electrical vehicle. Okay, so what are the different mechanisms which we have made for the it is a finite element analysis using the FEM software for the different kind of machines for our power rating, and what are the various vibration analysis which we have done. Okay, so these are some of the samples what I want to discuss on, and some of the works which we have undertaken, especially for this particular domain. Okay, we have considered only the role of electronics in the electrical vehicles. Okay, so here in this thing, okay, we have worked with something like a power quality, and we have made some on the hardware development on the various studies. Okay, but especially when we talk about on the things related to our present works, what we are doing right now. Okay, so I can able to show the present works. Okay, especially with help of the LLC converter and the totem pole converter we are working with. Okay, so this is what the one of the works which we are doing. Okay, this is for the onboard charger. Okay, which we are working with the 7.2 kilowatt electric vehicle onboard charger. Okay, which help of the LLC resonant converter. Okay, so here we have taken an AC system. Okay, it's a AC. Okay, it is converted to the AC to DC with a totem pole PFC converter, and then it is given to the DC to DC converter. This is called a LLC converter. LLC means, so here I need to have a L and C, LLC resonant converter. So this converter will be this is one which will be converting a DC to AC, and this seems to be the high frequency transformer. And then after that, so this will be convert my AC to DC, and then it will be given to the battery. Okay, so such a way that we made some analysis with a detailed code for calculating this closed loop mechanisms for varying this PA controllers. And we also made some onboard charging for the vehicles, something like what we have discussed right now. For the we are working especially on the isolated DC-DC converter. Yes. Yes.
Sir, nothing, sir. Please continue.
Okay. So we have used isolated DC-DC converter. So the major task over here is we are working with the design of HFT, high frequency transformer. Okay. So in the MATLAB also, I will show you some of the. So this is some of the LLC resonant converters. Okay. So same thing. Okay, for the open loop and the closed loop mechanisms we have developed for calculating the different values of C, because LLC consisting of 2 L and 1 C. So we are talking about, so the resonant tank will be the heart of the LLC converter. So we determine the frequency dependent behavior. Okay. So we are working with the soft switching of the converter. Soft switching means either ZBS or ZCS. That means I want to control the switching on and off while the zero. I want to predict exactly on the zero voltage switching. Many people will ask this question, sir, for DC to DC converter, why we are using this transformer? Why we want to use this transformer? Okay, so this transformer we are using such a way that what are the magnetizing inductance which we are using for the transformer, that will be help us to determine the for soft switching. Okay, for configuration for the soft switching only we are using this high frequency transformer, and also for the bidirectional power flow. Okay. So many people will ask this question, so for this particular battery charger, you are having one AC, you convert to DC with a rectifier, you are using a DC to DC converter, you use a buck converter or a boost converter, and directly you give to the battery charger. This will work, but the performance is a very big question mark. Very big question mark, performance. So to overcome the normal buck converter or a boost converter, we are proposing the LLC converter and also the dual active bridge converter. What is the difference between dual active bridge converter will perform the bidirectional power flow between the battery to source, but the LLC converter will contribute only for the unidirectional power flow. So we are making a paper, okay, I'm making a comparison between these two analyses of LLC and the DAB, and how in the DAB, how this transformer contributes for ZBS and ZCS. Because many people are working with the ZBS and ZCS, especially for the battery charging mechanism, for battery management system, zero voltage switching and zero current switching. How we can able to achieve that? Who will help us to achieve this zero voltage switching and zero current switching? The only person which will help us is with the help of this LM. Okay, so this LM will contribute for our ZBS switching and zero voltage switching. I will show the also. So we have been able to calculate. So the role of resonance, so whenever the mass flow, when the voltage is near zero, we are going to reduce the switching losses, and we can able to make a wide range. So we have worked with a different kind of closed loop system. Okay. So normally here in the ZBS procedure, why we want to go for zero voltage switching? Normal switching is enough. Why we want to go for zero voltage switching? Because to reduce the losses. Okay. So that is, I want to achieve zero voltage switching. How I can able to achieve zero voltage switching? Using the resonant tank, okay, that is available transformer. That is the reason I'm using high frequency transformer. Why I'm using high frequency transformer? To make use of the magnetizing inductance. Why you want to use the magnetizing inductance? To reduce the switching losses. Why you want to use the switching classes? Then I can able to achieve the ZBS. So that is the procedure. So the overcome thing, that is for this particular purpose, we have made a detailed calculation for the switching dead time. Okay, if you're interested, I can also derive a dead time calculation. So that means you're having the switch on the first switch, second switch, and third switch, and fourth switch. Okay, dead time interval means what is the I'm going to introduce a time between turning off one switch and turning off the next. Okay. So for an example, I'm turning off this particular switch. For an example, I'm going to off this particular switch. I'm going to turn on this particular switch. Okay. There will be some time delay. There will be some time delay. Between this off time, between this on time, there will be some time delay because this I'm taking this as a control action. So what I'm going to do between these two intervals between off and on, what is the time that has been produced? That I called as a dead time. So during this dead time, what will happen? What is the energy that is stored in the inductance of Lm? Okay, this Lm will be used to charge or discharge the parasitic capacitance of the switch. Okay. So it will use to, for an example, off switch means it will make some charge, and it will discharge. And the on switch means it will make some discharge, like that. So that is it will helpful because there will be some parasitic capacitance inside the switch. So this Lm that is available in the tank circuit will be helpful for charging and discharging the parasitic capacitance available in the switch. Okay, in the switch, especially during the turn-on time. Okay, so where we can able to understand that, where we can able to make this kind of analysis between the TD and TI. So this magnetizing inductance available in your transformer, this will generate the current which we normally called as IM. This IM will flow to this parasitic capacitance of the switches during the dead time. Okay, so we can able to understand that, this is the way, because many times the students will ask, so for DC to DC converter, why there is a need for a transformer, especially a high frequency transformer, why we need it? Okay, the reason is to make this dead time. So for an example, you are not concentrating on the dead time interval, what will happen? If the dead time interval you are not at all concentrating, that is, you are turning off the switch, you are turning on the switch, and you are going through the process. That means what will happen, so this will create some losses, and the performance of the overall charging of the battery will be get reduced. Okay, so the magnetizing current IM, which charges the parasitic capacitance. Okay, so what it will do, it will charge the parasitic capacitance of the off switch. Okay, and simultaneously it will discharge the parasitic capacitance on the on switch. Okay, so this particular action, because TD, the dead time will be just a nanosecond or microsecond only. As per my calculations for my system, it has come at a nanosecond or microsecond only. But this dead time calculation will ensure that the voltage across the switch will reach us to 0 before it turns on. Okay, so I want to make a estimation when the voltage across the switch is 0. Okay, in order to make it turn on. What will happen if I turn on the switch before the voltage is before the voltage across the switch reaches to 0 means, okay, there comes the losses. So in order to cope up this particular time delay, for the continuous procedure only, we are making use of the zero voltage switching. Zero voltage switching means anybody can say that I want to switch the device. I want to switch the device where the voltage across the switch is equal to 0. That's a very simple definition. But what micro level, what is happening over there? What is micro level? Micro level happening over there is with the help of the transformer. Yes, sir. Yes. Yes, sir. Ask me.
So nothing, sir.
Okay.
Somebody
So
turn on this unmute.
Okay. So let us talk about on the condition for the ZBS. Let us talk about on the DC to DC charger. If you want to make a thing means this magnetizing current should be greater than what is the value of your drain source capacitance of your switch. Okay. So I can able to manually calculate what is the value of IM. Okay. So I want to satisfy this particular condition. See, this you are having this LM in your high frequency transformer, LM. Okay. From the LM, I am getting this IM. Okay. So if I want to implement the ZBS, this IM value should be greater than my capacity, the parasitic capacitance of the switch and the drain source voltage of the switch divided by the dead time. Dead time you have calculated. So if this particular condition
అపీల్
satisfies,
అంటే అన్ని
you can say that we
డాక్యుమెంట్స్
have achieved the
సెలక్షన్
ZTS.
అయిపోయిందంట.
So once
Running
the
race and
voltage
IPL.
across the switch is zero, the gate will be turned on without any switching losses.
డిఎస్ ఇది ఉంది కదా.
That is the ultimate objective. So we can able to see.
ஆஹா.
அந்த டார்மெண்ட்ரி மாதிரி ஒரு இடத்த தந்து விட்டாங்க. அங்க வந்து இது பண்ணாங்க. ஏன்னா சரி ஓகே அது நல்லா இருக்குமான்னு பார்த்தா அது
హలో
వీళ్ళకి కూడా ఏదో రిక్వెస్ట్ ఉంటుంది పోలీసు వాళ్ళకి కూడా.
ఎడ్విన్ సార్, ఎడ్విన్ దీపక్. థ్యాంక్ యూ సార్.
So we can able to see that, I want to figure out the condition for the switch on. So I want to switch on. See, when you take across a power electronics, the normal turn on and turn off switches can be made with the different schemes. So presently we are writing a book on pulse width modulation. There we are discussing about analog PWM and digital PWM. Turning on the device and turning off the device is very easy. Even in the MATLAB, or even if you want to implement the hardware also, you just to purchase IR2110 and TL494, that's all. You can generate a PWM with the help of these two ICs. But I want to turn on the switches such a way ensuring that there should not be any switching losses. So to overcome the switching losses only, these kind of DC to DC converters, they are having this resonant tank circuit. So these are some of the output waveforms. Okay, so what typically we have achieved in order to make sure that, so this yellow color refers to the output voltage and this will refers to the reference voltage. Okay, so based upon these two intervals, okay, so this is a current waveform, so because we are taking a simple resistive load for the initial cases, and here we can able to see that, so this is a totem pole bridge circuit, and I can say that's all. Okay, so this is what actually I have taken up to 9-10. Okay, so if you have any questions, I'm very happy to discuss. If you have any questions, I'm very happy. So even these are some of the things related to vehicle to grid for the grid to vehicle, and this is one more thing for the electric vehicle components and charging systems. Yes, fine.
Good evening, sir.
Yes, ma'am.
Good evening, sir. Sir, can you
Yes,
please explain what is the concept behind this onboard charger, sir?
Concept onboard
Is there any
charger.
scope? Yes, sir.
Okay, so what do you want from the onboard charger?
Sir, everywhere we are having only off-board chargers, no, sir.
Okay.
What is actually the difference, sir, between this onboard and off-board charger?
So, ma'am, the onboard charger, offboard charger that is available in the vehicle itself, the amount of conversions what is takes place, that only speaks the difference. For example, if you take an onboard charger, okay, so what it normally does, it will receive the AC current, okay, from the grid, okay, and convert into direct current, and then it will charge the vehicle battery. That is called as the onboard charger. Okay, so onboard charger, mostly the people presently, okay, that is whenever they are talking about on the onboard charger and the offboard charger, okay, the major difference, the onboard chargers are built into the electrical vehicle, okay, so which will be something like for slow charging, whereas the offboard chargers means, it is designed for fast charging. Okay, so that is the difference. Okay, so why it is a slow charging, why it is a fast charging means, so the slow charging means onboard chargers you can take, onboard chargers you take that as a slow charging because it is charged by the AC system. Okay, so AC system charging will be always a slow charging. When you talk about the offboard chargers, okay, it will be fast charging. The only difference is power transfer.
Hello.
Okay, sir.
Yes, sir.
Hello.
Yes, sir.
Hello. Good evening, sir. I won't take much time. Albert, sir.
Yes, sir.
Just overwhelm him with your knowledge regarding electric vehicles, sir. And I personally think that I was quite unfortunate that I didn't get PhD seat 5 years back, because 5 years back I got selected for VIT Vellore PhD entrance exam, but due to certain
Okay.
reasons I got didn't appoint as a student. So I was
Okay.
quite unfortunate for this thing.
ఏంది
Right now I'm doing my
నోట్
PhD in Pune University, and
Okay,
my
sir.
topic is hybridization of lithium-ion battery and supercapacitor. So
Okay. Okay.
I have set the syllabus for Pune University, and I am just on the verge of completion of my PhD. So
Okay.
my basic question is ki, if you can give your some contact details like email ID or etc.
Okay.
So there are list of questions which I have, and due to this time foundation, I can't ask each and every question to you.
Okay.
That will be I'll be fortunate. It will be my pleasure if you can guide me. What other I can do research publication and etc. Right now I did 11 publication regarding that hybridization. Amongst
Okay.
five are in Scopus Index, and
Okay.
I just want few other what kind of topic or what kind of area I can
Okay.
work on further,
Okay.
because till
Okay.
now I just worked regarding structural thermal analysis and battery testing, like vibration, abuse, nail penetration, drop, impact, etc., using MATLAB, SolidWorks,
Okay.
and LS Dyna answers. But I want to
Okay.
go further beyond, because right I'm a mechanical engineer basically, and whatever
Okay.
you did knowledge shared, that was quite
Okay.
vast regarding electrical and electronics. So, as a
Okay.
mechanical point of view, I want certain guidance from you that how I can extend my publications or how I can extend my research work. And if fortunately in future I'll get a chance, that then I'll definitely, with your permission, I would like to meet you personally and to have your knowledge and to get certain things for my future life from you. So, if you don't mind, just can you please share your contact detail like mail ID or anything, so that I can in touch with you.
For your compliments. I was very happy. Okay. So what happened? I think Munishankar sir has not given permission for me to send messages in the chat box. So,
Sir,
okay.
Okay, Muni sir, it's a request to
please,
You
you.
can get directly
You are
from me.
coordinating very well from yesterday. So, if you
thank you.
can share that to me personally on my WhatsApp,
Sure, sir,
or you
sure.
can, Muni sir, if you can share your personal WhatsApp number, I'll send my request to you and then share Albert sir contact detail to me.
Yes, sir. I will share all the resource person details also, and I will share the PPT presentations also. No need to worry. Okay. You are free to ask any resource person in your research.
No, actually, Albert sir is the first person who's listen right from the start to end until I am not satisfied with his lecture. Actually, I want to continue his lecture for more 1 hour, but we are all family person. We have time limitation actually. So, Albert sir, it was really, really appreciable lecture from your side, and thank you very much for sharing each and every detail, because many researchers I have found that they want to hide their knowledge, they want to hide their papers, they want to hide their research work, so that other person should not continue. But you have explored each and everything. You didn't
Yes, sir.
hide anything, and you just like spread your hands. This is my knowledge. You can accept anything. So that was quite good for all our research upcoming researchers, and definitely I want to in touch with you with your contact details.
Thank you, sir. Anyone ask any questions? Okay, sir. Sir, coming to my side, sir, you explained a very clean explanation and a very interactive session it is. And there is a very enthusiastic participation and explanation in virtual environment itself. Sir, you explained each and every concept related to power calculations of electric vehicles and the various specifications in different very electric vehicles and electric vehicles charging schemes also. And also you are more interactive with your research publications, and you are very friendly, you are explaining with the participants. Okay, sir, we are very glad, sir, for being here with you. Okay, thank you very much for your acceptance as a resource person, sir. I will share your contact details with our participants. They will reach out to you, sir. Hello, sir.
Thank you, sir. Thank you. Thank you.
Okay, sir. Coming to this participant, sir, I will share already yesterday's feedback form. Please try to fill that feedback form, yesterday's feedback form, and now I will share the day 2 feedback form also.